Sure, sure. Thank you.
Just showing it. Yep. I think the recording is started and we are good to go. Okay.
Yes.
My screen is visible to all, right?
Yes, yes, Utkarsh. Yes.
Yeah. So I've shared two links in the chat. First of all, let me brief you about the links, and they'll be integral part of the session. Because just give me a second. Yep. Uh, so first is the catalog.nvidia.com. This is basically the NGC page. In this session, we'll be covering about NGC, what NGC is, why we need it, and how we'll be leveraging them in our environment setups for both your Singularity based and your not Slum based and your Docker based environments. Okay, so here you'll find different collections in terms of container models are there, Helm charts are there. So first is you create your account there. The sign in it's completely free. You'll understand the importance of this by the end of the session. And the next link I've shared is for GTC, which is our developer conference. So what once you register for that, the advantage of that is you can click search and video on demand, right? And every kind of lecture you want. Let's suppose I want something in healthcare, I want something in conversational AI, right? You can basically get the access free of cost for all the lectures which were taken or which were completed in the prior versions of the GTC. So this time around, the GTC is in next month, right? So all then the access will be given to you. Make sure you register from the link which I have shared. So if you want to work something related to deep stream, which is our SDK for intelligent video analytics, right? Surveillance, object detection, tracking, segmentation, license plate, all those applications in deep stream can be leveraged for that. So any kind of, if there is something related to molecular dynamics, genomics, HPC, then GrowMax is for that, right? So everything you'll find on this hub, I'll reshare those links. So once you're, just give me a confirmation in the chat with yes or no if you have created, and then we can go ahead. Everyone, is there someone who's still doing that? Because this will be leveraging for login and all that today. That's why I'm again and again repeating to do this task. Okay, I'll give another 2 minutes and probably then we can start with our session. Okay, great. So in this session, what I'll be covering primarily is what is the hardware that you have currently. Like, right, I'll basically cover the key features of the DGX system that we have. And then basically how you navigate that system, or you can say how to basically start with your different workloads. There can be vision, conversational AIs, like NLP can be there, speech can be there, HPC can be there, right? And different domains can be there. So how you can leverage NGC for that? And in terms of environments, some systems are using Slum and some are on Docker. Inside Slum, the runtime is en route. So we'll be covering both of those separately and showing you how to run job on your system itself. And that will be the entire workflow of today's session. Uh, So in terms of what are the different roles, I won't discuss this in much depth as all of you are already aware of this, right? But there are different deep learning roles which are there at different points, from data engineering to engineers to scientists to software architecture, right? All of these have different jobs to do. For example, a data engineer primarily works on EDA or ETL, which is kind of maintaining or preparing the data so a data scientist can work on the model convergence part, also preparing the model. The software architect focuses more on wrapping that model, which is being prepared by a data scientist or a researcher into application. A engineer or a DLOps engineer is primarily focused on deploying that and basically whatever application that is being built by a software architect for a particular purpose, how to make that scalable in deployment, right? That's a job of your DLOps, and also we have system admins for external and internal support. So this is how an entire pipeline and roles look like. And in terms of the development lifecycle, we have different starting points, but usually what we do is a data engineer, his or her job is basically to ingest, cleanse, and focus on storing the data and how to basically provide that data efficiently to a data scientist who works more sort of exploration and model prototyping, right? So it can be your experimental optimizations, preparing and tuning our model so that it is capable of doing the task which it is trained for very efficiently. Then once your pipeline or model is ready, the last step is, or whatever the last role is, your deployment, right? And also practically speaking, your deployment pipeline should be much more scalable. So for that, we have ML/TL engineers who work on building different kind of deep learning pipeline, which basically support different backends. So be it a TensorFlow model, be it a PyTorch model, any kind of Python file, or any type of backend, your application should be efficiently deployed, right? And should support multiple and different type of inputs, right? Be it Bash, be it streaming apps, any kind of, right? And the objective of ML and DL engineer always remains the same, right? And that objective is basically focusing on a much more lower latency and high throughput, right? By throughput, it means how much more queries your model can handle, right? And latency mean what is the delay in the response once your query is being sent to the model, right? So this is how an entire pipeline looks like in a nutshell, right? And we at NVIDIA, basically now we are more of a full stack company. So we work from both end to end, from your data preparation phase. So for that, we have different libraries accelerating that point or that bottleneck, which is always there while shifting the model and data from CPU to GPU to your deployment. So in deployment, we have various engines, or you can say SDKs, specifically like Triton is our general purpose inferencing server, right? We have Riva for conversational AI and DeepStream is for IV applications. So end to end, we'll support you on this in terms of whatever applications or research work that you are going or doing, right? In terms of factors behind the boom of deep learning, the point being the algorithms were already there. Research started from about 1940s, right? And they started building the bigger computers. But what the bottleneck was your computational power, right? Although they were building or focusing more sort of efficient algorithms, but uh, the bottleneck was in terms of computational power, right? And after the advent of internet also, the data was not a bottleneck in terms of availability, right? So all of these things, they joined hands in about 2010 or 2012 when the revolution started, and basically the boom of deep learning basically started because, for example, the back propagation was introduced in about 1986, which is an algorithm for training your deep learning models, right? However, with GPUs and with the availability of right set or right features in terms of data sets and collecting them with your deep learning algorithms, the boom in the industry came, right? And everything is history from that point onwards. Now, talking about the infrastructure, earlier or trivially, what used to happen is basically all the infrastructures or what was there in the infrastructure, it's very inflexibility in terms of some of them were working on you can say training, some might be working on analytics, some might be doing inferencing, some might be doing HPC, right? All of the person they used to have separate cluster, right? But now there is a quite interrelationship between different fields, right? And also let's suppose I want to deploy analytics and inferencing pipeline right together by ensembling them, then it becomes very difficult to manage these clusters, right? And also what it can result is non-uniformity in the performance across the data center. So this was what was there trivially, right? And the entire infrastructure was very unoptimized, it was very complex to manage and very difficult to scale. So for that uh, is anyone saying something? If there is any doubt, you can add in the chat parallelly. We'll address them like side by side. Okay. So for that, the solution for that was basically the DGX A100. So in DGX A100, in a nutshell, what we have 8 NVIDIA A100 GPUs. A means Ampere, so it's our Ampere architecture. The previous version was the V100. So in this, we have 8 NVIDIA A100 GPUs, each with the 80 GB, so 640 GB in total. For connectivity, and in terms of your clustering and storage, we have 10 Mellanox switches. So 8 of them are for your clustering. So you can connect the other GPUs with that. And 2 of them are for storage purposes. In terms of the CPU, we have dual 64 core AMD and with 2 TB of RAM. And the most important thing is now the GPUs, they are connected, interlinked by using 12 NV links per GPU. So the GPU to GPU transfer is about 600 gigs per second, and it's a bidirectional bandwidth. And in terms of the memory, so each DGX has 30 TB of Gen 4 and NVMe SSD, and like you can basically, if you want to expand or add more storage, that can be done, and it's quite possible. So this is the DGX system which is there on your IIT Bombay cluster. So I've already on in the system. So if I do NVIDIA SMI inside your cluster, you'll see these 8 GPUs are there and about 81 GB of memory is available and it's unutilized. So today in our training session, what we'll be doing is we'll be showing you how to do multi-GPU training, how to get started and all those things. But in a nutshell, this is the machine you're working with, right? So now the next thing is the features that are there in terms of your A100 DGX A100. So the few of the separating features in terms of the scaling is the Ampere chip. I already talked about that we have the Ampere architecture in this new A100 GPUs, right? Then in terms of the NVLink for efficient scaling or to enable your GPU to GPU transfer, right? And communication between CPU and GPU, we have your NVLinks and NV switches for that. Right, NVLinks are primarily for GPU to GPU communication here. Then the most important feature or what separates the entire thing apart from the performance is your multi-instance GPU feature, right? So usually what used to happen was, let's suppose I have 32 GB of my compute GPU memory, right? And I'm running an inferencing workload. So it's occupying about 5 to 6 GB, right? The other was not isolated, right? I can run the training on the other remaining 25, 24 GB, whatever is remaining, but there was no proper isolation. Let's suppose if I want more compute, right? But then inferencing is running, there is no proper monitoring and no virtual partitioning of these GPUs, right? So as a result of that, moving from our volt architecture to the Ampere, all the Ampere cards, A100, A30, right, they have this multi-instance GPU feature, right, where you can slice your GPUs, virtually slice your GPUs into like 7 partitions at a max. So for example, what I mean by that is, let's suppose you have 80 GB of GPU memory. What you can do is you can create 7 partitions of that. So about of 10 GB each. So at the most on one particular GPU, 7 users can work on that. So on one DGX server, 56 users can work at a time, provided they only need 10 GB of compute. Then the other feature in the A100 design is the third generation tensor cores. What I mean by that is we have different CUDA cores, we have different tensor cores for your tensor operations, right? And they are for different type of your floating point precision numbers. So here what we have done is we have introduced a new standard which we call TensorFlow 32, right? So what TensorFlow 32 does is it follows the range of your FP32, but the exponent part it follows of your FP16, right? So it's a combination of both. So when you train the model with TF32 enabled, it will do the optimizations in terms of, for example, when we do mixed precision training, right? Some might of you have heard of that, where we train on a mixed precision our model with FP32 and FP16. This is the kind of hardware level optimizations where we basically provide the right set of tensor cores for doing that particular operation. And at last is the sparsity acceleration. So sparsity is one optimization technique that holds the promise of meeting all these goals. What I mean by that is if there are zeros in the network, then you don't need to store or operate on them, right? So it will automatically ignore those nodes or whatever those zeros are in the network, and it will accelerate. Again, this is a hardware level acceleration, right? And the advantage of that is it will provide you acceleration, accuracy, and workflow uh, enablement and efficiency in that, right? So with that, what we observed was about 2x performance gain with the sparsity acceleration. So in a nutshell, these are all the features in the A100. But I already talked about MIG. I want to discuss this in much more detail, right? So what you can do is, let's suppose I am a user, right? I'm doing a GPU training, right? I'm doing a model training, and I'm using my Jupyter Labs, right? And my colleague is doing some kind of inferencing workload. Some of my colleague can be working on HPC, right? So what you can do is this infrastructure, the most like the beautiful thing of this is it resolves the inflexibility which we talked 2 slides back. Basically, it means if you want to run AI workload, you can do that. If you want to run analytics workload, you can do that. HPC, you can do every kind of workload. You can basically do just that. You need to fix the memory and whatever tensor cores you want for that particular operation. So what I mean by that is, so in this case, as you can see, we have allotted, so we have partitioned our GPU. So there are three, 1, 2, 3, 4, 5, 6, 7, right? 7 are there. We have partitioned one GPU into 7 slices. So up to you can slice one GPU to 7 of 10 GB each, but this user is taking running some Jupyter workload, right? So there are different configurations which we have presented by ourselves. One is a 10 GB, 20 GB partition is also there, right? If you want to work on 40 GB, those partitions can also be created. It depends on what type of workload you want to run, right? You can allot that student or whosoever the researcher or the research group wants to work on, right? You can allot those kind of instances accordingly. So all the MIG instances, they run in the parallel, right? And your quality of service is maintained across the MIG instances. So the underlying L2 cache and your basic, you can say, the partition GPU into smaller GPU instances, they all have their own like SML2 GPU memory, right? And the proportionality, they share their bandwidth, right? And just give me a second. Sorry for that. This is what is MIG. So you can set the configuration. It's like we already have the repository, which is NVIDIA MIG parted. Let me search and show you that repository for reference. So this is the repository, like we have already created the different configurations. So you can see this configuration is for the 40 GB variant. For 80 we can change accordingly. So there here will be 1 G 5 10 GB will be there, and 7 instances will be clear. So you just need to clone and use this, and you can create the slices accordingly by the configuration files you want. So this was about multi-instance GPU. So moving forward, just give me a second. Is container overview. So before that, let me reiterate the pipeline that we discussed in the initial slides, right? I won't discuss in detail, but it's like the gist of the slide is that there are a lot of moving pieces. So the data engineer needs to do ETL, feature engineering, right? Then there is data scientist is there, right? Who needs to work on your training, adapting, optimizing the model, different techniques like pruning, quantization, all those things data scientist needs to take care. Then we have developer who builds and who optimize the app, and then we have DevOps who deploys. So you can see a lot of moving pieces are there, right? But at the end of this module of the session, which is the NGC, before we start into Docker, you will notice that this we have optimized the entire pipeline, and the only reason for that, or only factor for that, is by leveraging NGC. So NGC is the key, you can say, thing that we need to understand. We need to shift our focus to that. Almost whosoever develops or who wants to do any kind of development or research, rather than setting up anything from the scratch, it's the NGC which is the place to start with. So before we jump into NGC, I just want to discuss a difference between virtual machine and containers. Right. So virtual machine or VMs, it's nothing but it's a standalone, and it has its own operating system, right? And every instance has its own guest operating system, right? So the following schema we can see, like every virtual machine uses its own OS libraries, right? So the implication or the consequence of this is they occupy significant amount of memory, right? But what happens is, you can see these all instances of VMs are built on top of the hypervisor. Hypervisor is nothing but it is a VMM, which is virtual machine monitor. So it's a software that creates and run the VM. So these VMs we are creating with the help of this hypervisor. So it allows one host computer to support multiple guest VMs, and it shares the resources. By resources I mean memory, processing. But the issue of this virtual machine infra or environment is it's very resource hungry. It takes large amount of time, a lot of overhead is needed. The reason being, every time it needs to boot a new operating system and the setup needs to be done, and it's a kind of time consuming and a resource hungry process, right? So the alternative for that, it's the containers. So they do not contain any guest OS, you can see, right? But what we have is they simply share the host operating system. So the layer for host operating system will remain the same. So it includes all the kernels, libraries. So you do not have to boot the full OS as you were doing in the virtual machine. So in terms of the benefits of containers, they have a faster startup time. So it can basically or usually start in a couple of seconds. We'll see today how easy is it to like install your not install, start your containers, right? And basically uh, it removes all the hassle of installing any libraries or whatever binaries or dependencies you need for running your application. You just need to figure out what workload and in what umbrella does that workload come under, right? Whether it's something related to deep learning, whether it's something related to HPC, if it's relating to deep learning, whether you need specialized models, whether you need to use only PyTorch, whether you want TensorFlow, all kind of this questionnaire you can do, and then you can figure out the container. Just pull that container from NGC and you can, like, you're good to go. It's as simple as that, right? Another thing is there is less redundancy with containers. So with virtual machine, you have to install this guest OS entirely, right? So there is a lot of duplication in terms of components which are running on the host server. So the containers, they do not require all kind of the settings and all that. Next is in much more detail, what is a container? So it's nothing, it's a kind of, you can say, a Docker. So for container, there are three runtimes generally which we use. One is your Docker, then we have enroot and Singularity is there. Okay, so today we'll be covering both Docker and root. So a Docker container, it's a mechanism for bundling a Linux application with all of its libraries, data files, environment variables, so that your execution environment is always the same on whatever Linux it runs, and between the instances on the same host. Okay, so what I mean by that is you can bundle all your layers you want to in your base image, right? And that image you can replicate on any system you want to. You just need that tar file of that image and we are good to go. Just unzip and load the image and run it using either Docker, Enroot, or whatever environment you have. That's the advantage of container. So it removes that reproducibility bottleneck which is there, which is a very big issue in terms of your simple environments which we set using CLIs. Next, you can package and execute your environment into one, right? And your deployment is very easy. It's needless to say, you just need to deploy a container in your inference server and we are good to go. And the cherry on the top is the performance. What we have observed over the days is there is no uh, you can say drop from the virtual machines. Above all, it's better performant in terms of your the speed up compared to the virtual machines, and it's there is no loss in terms of accuracy also. And it can run on any like application can run on any system with a container runtime, right? I already discussed this, that you can have just have an image and run it on any system. That's the advantage of containers. Now Docker. So before understanding what Docker is, there are two aspects which is very important to understand. That is the difference between the image and the container. Okay, so all of you might be aware of what is class and object. So one is a runtime of a class. So what I mean by that is the same analogy is there in the image and a container. Image is basically a static thing, right? So where we have stacked a lot of file system in a layer wise fashion, right? And whatever you want, you can keep on modifying the image and commit it, right? So that from next time onwards your research group uses that image. It's up to you, right? But when we run the image, the runtime instance of an image is a container, right? And you can run those images using any kind of um, environment. Here when you run using Docker, it will be a Docker, we'll just attribute that as a Docker image and your Docker container environment. So a Docker container will contain a Docker image which we have ran, obviously the execution environment and the standard set of instructions which are already wrapped inside it. Next part is your NVIDIA. Before we jump to NVIDIA GPU Cloud, just I'll quickly discuss this training and inferencing workflow, which we usually follow for AI, right? So there is one more step in between, which is your optimization. Recently, like it has created a lot of trend and boom in terms of, you can say, once we train our model, although we quantize or prune, there is another step we can do, which is the optimization. So in training, what we can do is we can have your data repository, or you can say the data, and then we've trained depending on the whatever framework we want to use. You can use PyTorch, TensorFlow, right? And then train and we get a trained model. Once we have iteratively trained our model, right, and freeze the model, the next step is basically deploying that model for inferencing. right? So for that, what we do, we just take a input data and we pass that through the model which we have done, and we'll get the insights. That's what inferencing is. There is no back propagation, or you can say the training phase, or what is most responsible for your optimization of the algorithm, or not the algorithm, optimization of the model which you are training or trying to make capable to solve a particular task. In terms of the hardware infrastructure underlying, for training, you can leverage both the multi-cloud or on-prem system which you have, or if you want to use hybrid cloud, that's also possible. For inferencing, we usually use edge-based or hybrid cloud, different types of, depending on the load, we can do that. But usually the inferencing is done on the edge, right? But if you want to deploy anything on your system, that is also possible. It depends on application to application. Next is NVIDIA GPU Cloud. So we'll jump to the website also, but before that, I'll quickly cover the slides so that we can focus more on the hands-on section of the NGC. NGC stands for NVIDIA GPU Cloud. So what I mean by that is basically all of you might be aware of Play Store for Android and iOS Store for your Apple systems, right? It's a similar case, but it's basically for your accelerated applications, and it's a kind of Play Store which is developed and maintained by NVIDIA, and it's completely, you can say, all of you, I hope, might have created the account till now, right? And I'll show you how to start with NGC today. So you have different containers, again depending on your load or whatever application you are developing, the pipeline, you can just select that container, and that's it, you are good to go. We have pre-trained models. Sometimes everyone has their different set of environments already set up. They just want to uh, take the models. So we already have done that due diligence of training the models on enormous amount of data. You just need to take the pre-trained model and just wrap it around your own data in terms of fine tuning, and we are good to go with the deployment. Sometimes what we have done is we have also created some specialized SDK and frameworks. So for example, for healthcare, we have Monai and Clara. Your For deployment in terms of intelligent video analytics, we have Deepstream. For training your conversational AI, or you can say NLP models, we have Nemo. So there are different frameworks we already have done, so that it becomes very easy for you as a user or a researcher not to take, or you can say, focus much more on your optimization or setting the environment, all those trivial things, right? Rather than more focus can be on your what the pipeline should be, or how your model should materialize, all those kind of things. We also have Helm charts as a Kubernetes package if you want to do the deployment or whatever pipeline for you want to build there. And there are basic task based collection also, depending on your field which you are working. And again, all these containers or environments we give on NGC, they are supported on any type of infra you want. Uh, you want or you have. For example, if you are working with on your GPU, you'll use our basic PyTorch container which we have. But if you are using your edge device, right, then we have ARM-based containers already done and prepared for you. So for that, you use our L40 containers. For your DGX or this machine which you are leveraging, you can use our basic containers, which I'll show you today. In terms of the other advantages, so basically with the NGC container, what the value add is, again, you can run anywhere, right? It will give you the same performance on bare metal, VMs, Kubernetes, whatever kind of environment you do, right? Again, same thing, any kind of runtime you want from Docker, Singularity, and root, our containers are compatible with that. We have already done the optimizations. If let's say you want to train your or fine tune your BERT model, right? So we already have done the optimization in terms of the support for multi GPU and multi node systems, right? Which is there in your case. So that model parallelism, data parallelism, all the threading thing which is there in the model, right? incompatible with the hardware. That all support is already presented in the different containers. And needless to say, we have already scanned for vulnerabilities and the other privacy related issue that might arise on using such things, right? So they are fully secure, and I'll show you that there is no need of like taking concern about, hey, I'm using a PyTorch container today and tomorrow it will be deprecated. We update the containers on a monthly basis with the optimized software, right? So there is no need of updating like explicitly if you want to. But if you want to wrap certain applications which are not there, like I'll show you today, for example, we'll install some applications in a container which are not there, libraries, right? And then you can commit that commit the image, and from next time onwards you can use that image moving forward. So that feature is also like possible using Docker. And then needless to say, any kind of workload you can leverage our containers for. Why NGC? So I've already covered this. The software we have created for you, right? Performance, we have optimized the models, we have optimized the pipelines, all the pre-trained models are there, right? And as a validation, we are the winner, proud winner of the MLPerf competition, which is an industry benchmark standard for what the hardware acceleration is on the same model to achieve a certain target, right? It's tested across multiple platform, and you get the support from enterprise, right? Enterprise grade support is available. You can deploy anything. If there is some downtime or issues you can face, or you are facing, right? Then you have the access to the NVIDIA AI experts, and they'll help you with whatever issue you are facing. In terms of a specific optimization libraries, these are a bit of base libraries, right? So one of them is cuDNN, which is stands for CUDA deep neural networks, right? So whatever implementations in PyTorch, let's suppose con2d, relu, or whatever PyTorch based implementations are there which will leverage very commonly or routinely, all of those are optimized by the cuDNN library, right? And it's the base for whatever pipeline we are building for the operations, or you can say modules using the PyTorch. Kublas is again another thing, but it's for your matrix multiplication. So it tunes the gem operations which we do if we are building a pipeline very specific, which is more focused on your matrix multiplications and those kind of operations. DALI, it's basically for moving your pre-processing pipeline to GPU. So as I already told you, the one of the biggest bottleneck is moving your data from your CPU, that is your host, to the device, which is the GPU. So DALI basically what it does is, in terms of the pre-processing, it accelerates that. So that's the application or SDK we have. We have Nickel. Nickel is NVIDIA's collective communication library. So for any kind of multi GPU training or multi node training, this is the framework which will allow, not the framework, the library which will allow the conversation between multiple nodes, multiple GPUs, right? And the cherry on the top is it's compatible because we work very closely with the PyTorch team so that the optimizations are in sync, right? And they are seamlessly integrable with each another, right? So that's the thing in terms of the base libraries which you can leverage for your training purposes. Now, again, coming back to the same slide, but you'll notice in the below section, we have compressed our pipeline. For data engineering, you can use our containers, right, to accelerate ETL. So we have Rapids for data analytics. So you can leverage that if you are running any kind of analytics based workloads, right? You are aware of your data frame, right? You are aware of scikit-learn, where you use my machine learning algorithms. All those kind of things we have accelerated using our own GPUs. We have accelerated, right, and provided that under the umbrella of Rapids. So for that, it's like QML is there for machine learning, QDF is there for CUDA data frame, and then for pre-trained models is there for simplifying the training process. Similarly, SDKs for building faster. Let's suppose you want to deploy your conversational AI pipeline, right? You just simply need to use Reba for that, and we are good to go. And similarly for deployment, we have different Helm charts available. Again, for training and refining, I won't discuss in much in detail because as a follow-up training, we'll be discussing these SDKs in much more detail. But again, the in a nutshell, the story remains the same, that it's the application that you need to figure out which you are trying to resolve, and you will get the parallel and the state-of-the-art model for that on NVIDIA NGC. It's just that you need to understand the pipeline, and you are good to go for that. So any doubts till this point? We are going to start with the hands-on. Please feel free to ask any doubts. Anyone? You can message in the chat. We'll address them. No doubts and no one? Okay, great. In a simple terms, what is a container? Okay, so in a simpler terms, it's a kind of, you can say, isolated environment, right? And for that, before understanding container, you need to understand what is image, right? So, sir, are like, did you understand what is image, or you want me to explain that also?
Better if you explain.
Sure. Once I have my own container, I can install Update Library container without changing other containers. Yes, you can do that. So image is basically, you can say, a static thing, right? In image, what we have done is we have installed or you can say stacked various dependencies and libraries which we need. Okay, so let me go to the NGC website and explain you. It might be much more easier to explain and understand. So let's suppose I want to run PyTorch container. Okay, so now if you are using PyTorch, the all the dependencies related to PyTorch, you need to manually install all those on your CLI. What I mean by that is, this is my DGX, right? Let's suppose I want to run anything related to PyTorch. Then here I need to install that, right? Apt install, pip install, all those kind of things I need to do here. But this is my base operating system. Ideally, for proper isolation, you should basically separate the environments from each other, so that let's suppose I launch a container today, or a isolated environment, virtual environment. Then once my work is done, I can destroy it. Your underlying hardware, there will be no change in that except the volume mount which you have done. Right. So image is just a static thing. It's like a class. You can say, in an analogy of a class and an object. When you run that image, it becomes a container, right? And in container, all the libraries or the binaries which you have stacked inside your layered system of the image, that is there inside the container. So for example, once I pull the image from NGC, right? So I'll show you in the hands-on. Once I pull this image from here, then when I run this image as a container runtime environment using Docker and do pip list to show you all the libraries, you'll see, and you'll be surprised to see all the dependencies which you use: scikit-learn, pandas, torch vision. All those are already pre-installed and pre-built inside this image, and you have run it using Docker, which is a runtime for a container, and launched it as a container environment. So did that answer your question? Any follow up to that?
Yeah, cool.
Okay, you'll get more clarity when we do the hands-on. So probably we can take a quick 5 minutes break and then we'll reconvene at 3 and we'll get started with the hands-on section. And we are here only. You can add any other doubts you want to add in the chat and we'll address them as we get it.
So,
Hello, just can I ask
yeah, yes,
any question now?
yes, you can ask a question. Yes, you can ask.
So basically, I mean, in our type of work, I mean, I'm from Department of Chemistry, so I'm working with a deep learning program. So here, actually, we used to do something called Anaconda environment. So suppose in Great Type Job Submission, we used to create and different environment, so in which we can install our own library like PyTorch and scikit-learn. So is it that part similar to this container part? I mean, suppose different Anaconda environment, is it similar to the container or
Yes.
anything else?
So that is a very good question. So here, Utkarsh showed one slide to you where he was explaining the difference between virtual machine and containers, right? So I would say containers is like a virtual machine only, which creates an isolative environment for you without you without you actually installing each and every library from scratch. Okay, each and every library, I mean, if you take Anaconda's virtual environment, right? So what it will do, it will take the host or the bare metal systems, CUDA, CUDN, and whatever is installed there, and on top of it, whatever extra library you will add, like PyTorch, scikit-learn, then or it will create the environment. Okay, that way you are doing the manual work of creating the entire package, which you can do, of course, but there might be sometimes the cases where the PyTorch which you are using is not compatible with the CUDA version which is installed in the bare metal system. So in that cases, you might lead to some sort of you can say errors, or you can say less performance kind of things you might face. Okay, whereas in case of containers, right, what we have done, we have took the entire package. Again, I'll explain what is container. Container is like a package. So by the name itself, you can think it's like a container. It's like a box where all the necessary libraries, be it PyTorch, be it TensorFlow, be not if I say a container of PyTorch, then inside the PyTorch container, there will be PyTorch will be installed. There will be pandas there. Scikit-learn would be there. There will be necessary other peripheral libraries like Torch Vision, Torch TensorRT. All these will be automatically available there. NVIDIA engineers has done that and packaged them into one environment and uploaded at a place called as NGC. With this, they have also incorporated proper versions of CUDA, cuDNN, NCCL, and the hardware level libraries which are involved to run GPU accelerated workloads into it. Okay, so when Utkarsh run this container, right, you would be able to see whatever container. Currently, he would be taking the PyTorch container, right? So when he run this PyTorch container, you would be able to see inside that all these libraries are already there, which you are mentioning, like PyTorch and Flow, everything. So you don't need to create any Conda environment inside it. You just have to do pip pip list and you will be able to see all libraries are already there. And if you feel something is missing, for example, cbon is not there, so you can do simply pip install cbon. It will install in that particular container itself. Okay, so you don't need to actually use conda anymore now, but you can means you don't need to use conda environment anymore, but you can use conda inside the docker as well to
Okay, okay.
install any library.
Yes, yes,
So
I got.
we can show pip install by some new libraries which are not present in this container, and we can also show with conda as well. So you can get the idea, and you can save that also. Okay, so that next time you don't need to run, you don't need to do it again.
Just sir,
Okay.
stay with us for 15 minutes and like all your doubts will be clarified when we show you the hands-on section
Okay.
and
Definitely.
while running them. Okay.
Okay.
Uh,
Also, we will be creating one Slack channel so that in the teams we cannot track all the answers because it will get removed after the session. So we are creating a Slack channel for communication with us. If you have some doubts, smaller things or so, we can have that. I'll share the
after
link. Yeah.
after the
Uh,
session, like
After the session, we'll share.
yeah. Yeah. Any other doubts? Anyone? Please feel free to ask.
Okay, hello.
Yeah. Go ahead.
So this container is kind of Google Colab Pro where everything is installed already. We just need to get it. Can you compare it?
Sorry, what is the question?
Like in Google Colab, I mean, we
Yes,
do all
yes,
the calculation in cloud, so already things are there, right?
yes.
Okay, okay.
So
Thank you.
no, Google, what they have done, they have so Google Colab and there is Google Cloud. So in Google
Yes,
Colab, they are not using containers, but in cloud, there are image you heard, right? There is image
yes.
what. So there also you can use NGC containers, Docker
Okay.
containers or such
Mhm.
things. And there also you'd be able to find them running. And even if you open the page, which Utkarsh, can you go to NGC page?
Yep. You want to show Google Vertex? Is it?
Yes, yes.
There it
So
is.
here you can see on the right side there is deployed to Vertex AI written, right? So Vertex AI is Google's cloud only. So you
Okay.
can take the NGC models or Docker models into NGC and run that. So there itself it will create the image where this PyTorch framework container would be available and you would be able to run. And inside these PyTorch containers, you would be able to see almost 100 libraries are installed when you do pip list. Okay, so
Okay.
uh,
We'll show that.
yeah,
We'll show that.
and
Thank
those
you.
are what we have incorporated here. Yes.
Any other doubts? I'm addressing one in the chat. So installing a library in a container will make that library available to all others who wish to use the same container. Yes, you can do that. It's just that you need to commit that container, right? Create a new image. So now the newer image will have that new library, right? So there is, let me take a simpler example. So some might of you are aware of OneDB, right? Which is weight and biases. This is this library, right? You for tracking your experiments or everything. So you can do pip install 1db, then commit that, right? And in the newer container, your runtime will have that installed again, right? So you do not need to do the reinstallation. It already have pre-installed 1db layer inside the new image which is created, right? I hope that answered the question. Any other doubt? Yeah, we'll be showing that. Okay, so we can start, right? Okay, cool. I hope everyone has created an NGC account here, right? So this is the page you'll see on NGC, the home page once you do the login, right? Here your username will be there. So let's get started one by one, step by step, and demystify what NGC is. First, let's start with the containers. So we already talked about PyTorch, TensorFlow. These are basic library space containers, right? So let's suppose I'm working with TensorFlow, right? Then you search TensorFlow on Google on this NVIDIA NGC, and this is your container which is already present. And here what you can do is you can see there are various versions. So 22.07 means it's the June 7 version, like it's the June month version, so we update every month. This is your sorry, this is July, this is June, this is May. So all the libraries which are necessary or which are related to TensorFlow, they are already pre-installed in this library. Similarly is the case with your you can say PyTorch, right? But let's suppose you want to work something related to molecular dynamics for HPC. Then we have GrowMax for that, right? You can use this container, just copy this image. We'll show how to pull a container, how to get started. If you want to do something related to DAMD, which is again another molecular dynamics, you can do that. All the containers are there. If you are working on something related to medical imaging, we have Clara for that, right? So Clara Parabricks is for genome sequencing, right? Clara imaging, this is the Clara train, right? This train has all the models related to segmentation, brain MRI, liver tumor segmentation, classification, detection. All the models related to the medical are already present inside this Clara train. Right now, the next is basically, let's take an example of speech, right? So for that we have Nemo. Nemo is for conversational AI, right? So if you want to train your conversational AI pipeline, you leverage Nemo for that, right? If you want to deploy something related to video analytics, you have Deep Stream for that, right? So we have prepared these containers with a set of models which are already there, ready to be deployed for your use, right? Then there is this Tau toolkit. So Tau toolkit is for training purposes of vision, right? So all the models, so you can see traffic camnet, PeopleNet, 2D pose, 2D pose estimation is there. Your vehicle make net, people segnet, all license plate related. Every commonly used model, it's optimized. We have added YOLO support also, right? So all these models are already present inside this tower, ready to be used for you when you run this container. In terms of the models, sometimes you want to use a particular model, right? You can do that also. Let's suppose I want to use a conformer model, which is a ASR based model for your your speech to text, right? So if you want to do anything related to Hindi, let's suppose you want to transcribe your Hindi speech, then there is this conformer model which you can leverage, right? So there are different models which you can do if you want to do something related to, again, let's suppose mm, brain MRI, right? Then we have related to models related to brain segmentation. These are models, right? So you can download the models. We have already trained on enormous amount of data. So this is a segmentation model. So it has four classes: this red, yellow, and green, and fourth is the background, right? So if you want to leverage this pre-trained model for segmentation of brain tumor, you can leverage that. You can directly download. In terms of the collections are more sort of from a bigger picture. So for example, I showed you the Clara train, Tau toolkit. Morpheus is something related to cyber security, right? Then Riva is something related to your conversational AI speech, right? Then we have Nemo, we have HPC collection. In Clara also we have added the NLP for healthcare, right? Your NER models for recognizing the health related text and your name entity recognition. So different, we cover almost every domain. We touch everything, like for example, your question answer pipeline is there, text classification is there, speech recognition, NER, all of them is pre-packaged image segmentation classification for your use from this NGC, right? So today, as a demo, what we'll be doing is we'll be getting started with this NGC. Let me go to this system. uh, hmm, okay, so first let me log out so that I can show you from the scratch. Docker logout nvcr.io. remove my old credentials. I'll clear. So the first thing is once you have created your account on NGC, you just need to click on setup. So is it visible to all? You want me to increase any like zoom in or anything? Can anyone confirm?
Should be better
It's
if
okay.
you can zoom in.
Okay. Let me try. Just give me a second. Is it more readable now?
Better.
So
Yes, yes.
okay, cool. So here you will see your name, right? Your username. You need to click on setup, and this type of screen will come. Then you need to click on get API key and generate your API key here. Okay. Every time you click generate API key, your older API key will become invalid, and you will get this new API key. So before that, what we need to set the configuration for NGC, right? So for that, we copy this command and we run on the system. So we run ngc config set.
So one comment is that can you go something slow? I mean, it is very difficult to follow up you. So actually, I forgot. I mean, where is that point? API key, I
Sure,
couldn't find
sure,
that.
sure, sure, sure.
So can you go again?
Yeah. So cool. Let me repeat. Anything you want me to repeat from NGC, or this process you want me to start again?
So I could not find the API key. I mean, I don't
Okay,
know.
okay, sure, sure. So you click on your username, then you click on setup. Okay, there. So is this screen visible to you, sir?
Yes, yes.
Okay. Now you need to click on get API key.
So here, in my case, it is only showing the CLI format, CLI documentation and downloads. And
It's showing CLI documentation
So,
download.
sir, you need to first log in into
Login.
the system. Then only you will. So here you can see on the rightmost side it is Uppal written. Means it is Utkarsh Uppal's. He has logged in. That's why he is able to see. But in your case, it
Okay.
might be welcome user something
Let
written.
me log out
Okay.
and start from the scratch.
yeah,
So first login is required.
yeah,
Yep. And for that, you need to create the account. That's why we shared the links in the starting. Let me share that again. Yep. So you can click on NVIDIA account if you already have. You need to create. Okay, you might have clicked on continue as guest. That's why it's not available. So I'll do the SSO login, right? And I'll add my NVIDIA email ID here, right? Which I've already registered here. So I'm logging using the SSO, and then I'll click on next. So now my NGC page is going to start, and it's going to load for the purpose. Here you will see your different organizations. It might or might not be visible at a time, right? Because you have created your new account. So you can select any organization if anything is coming, right? And then you will see this username here for your case. Okay. Here you need to click on setup, and now it will load and you will get this generate API key. Okay, so I have clicked on this generate API key, right? And here I need to before generating the API key, I'm running this first command, which is ngc config set. Okay, sir, did that page come for you?
yeah. I'm trying. So yeah, you can continue. I can follow you.
Sure, sure, sure. Then the next step is basically I basically wrote the ngc config set command and ran it in the terminal. Okay, and I'll now it's asking for me to enter the API key. Somehow I'm not able to zoom in this.
And for your case, please do not use sign in for sign in means SSO one. Use NVIDIA account because it is for new user to create in the page, NGC page. There will be two options, NVIDIA account and SSO. So use NVIDIA account and create your user. There you need to add your credentials as well, like my email ID, what would be the password and organization. You can write IT Mumbai and all.
So, is it visible? I'm not able to like zoom in this terminal. I
It's
don't know
okay.
why.
It's okay, Utkarsh. We can see this.
Okay, cool. So
Hello,
here, yes, sir. Go ahead.
Utkarsh, you can use this full screen on this any desk.
Sir, I have already enabled that. This display settings my is already stretched. Let me try the full screen mode also. So when I click the full screen, it's becoming too small. No, not happening. Okay, never mind. Like I'll try to explain the command as we go on. There it is.
Yeah.
Is it better now?
Yes, I can see.
Okay, great. So I I copied this ngc config set command from here, right? I hope everyone got this page. So I'll explain again from your setup. I click just on your setup and in setup you'll get this generate API key and click on get API key. Okay, so I've copied this first command, which is ngc config set, and I've ran this command. Now it's asking me enter the API key. Okay, so for entering the API key, before entering, what I need to do is I need to generate one, right? So once I generate a new API key, my old API key will become invalid, right? So I click on confirm and my new token is this, or this is the same API key. Okay, so I copy this and I'll paste in the terminal, all right? So I paste the API key here and I'll click on enter. Now it's asking me the CLI format, right? Let's go with ASCII. It's asking my organization. Already it's I'm writing in VDN. So these options I can ignore also if I want to, right? So now my team. So I've added a team name here. Here there is no need of adding this. Then
So in your case, you won't get these many flags. This is for NVIDIA specifically. So you only will get the API key and the CLI output format you want. That's it. Then you will be able to log in.
so you can see here we have seen the like message that I have successfully saved the ngc configuration, right? So now the next step after we have done the configuration set, it's basically your logging into nvcr.io. The reason we need to do this is so that we can leverage the containers which I showed on your ngc page for your workload or whatever work you are doing, right? So for that we need to log. we need to log in, right, and do this nvcr.io login using the Docker here, so that whatever containers we want to pull from NGC, we can do it without any hassle. So it's asking the username. So username again, the same page has every detail. A username will be auth token, and this username remains same for everyone, not only for IIT Bombay. It remains same for everyone throughout the world globally, which is auth token, right? So I add this username. Now it is asking me the passcode, right? So my passcode will again be my API key. It's already written here. Password is this. So I'll copy this, right? And then I'll paste this API key here. And then I'll click on enter and my login is successful. Okay, so now what I can do is I can run my basically when I do Docker run, or I pull a image from I want to pull an image from NGC, I can do it without any hesitation, because now my login is done, and whatever access permissions I have, based on that I can do that. Okay, so the next step is once we have done the login, the next step is pulling the image, right? But for that, you need to understand a few commands of Docker. First is Docker images. Okay, so Docker images will do what? It will basically list all the images which are already present in the system. So here you can see we downloaded a few images a few days back for our work and this demo purposes. So you can see all the images in this system which are present, right? So you can see there is no TensorFlow image. We downloaded the PyTorch images. Then the other command is, okay, we'll get to other commands gradually. So once the login is done, right? Then the next step is basically selecting the container we want for our workload. Okay, so let's see. Let's download any TensorFlow container, right? Image, sorry. So for example, this is the TensorFlow image we want to use for our use case, right? So I'll click on this copy path and let's select the latest version, right? So my image path is copied here. So what I need to do next is, after the Docker images, it's Docker pull. The reason we are using the pull is we are pulling the image from the NGC for this case, right? And primarily and specifically, we are doing the TensorFlow image, right? So we've done the Docker pull nvcr.io, right? And you can see it has started pulling the image from NGC, right? And there are different layers. These are layer IDs which are all there for different binaries, right? So it will start downloading, and this TensorFlow container, it's about 5.55 GB. So when this process will be like I'll stop this now because it will take some time to download, right? So let's stop this process, and what will happen is, once you download this image, or once you pull this image and you run your Docker images command, you will be able to see a TensorFlow image here. Like there is a PyTorch image, there will be another image which will be a TensorFlow image, right? So we already have downloaded a PyTorch image for reference and demo purposes today. So once you have pulled your image, the next step is running that image using a container runtime, so which is Docker, and creating a container environment for that, right? So for that, for our purpose today, what we are doing is, for that we can use Docker run command. Okay, so I'll again explain what all we have done till now, so that everything is clear. So the first thing that we have done is your NGC config set. We have done the configuration setup, right? Then what we have done is in Docker login nvcr.io. Then what we have done is we selected the image we want for us. Selected the image for our use case today for PyTorch for Vision Transformer, right? We need a PyTorch image because our code is developed in PyTorch, right? So for that, what we have done is, once we have selected this image, what you can do is you can do Docker pull and your image. This image path you need to copy from ngc based on whatever container you want to use, right? Any doubts till this point, anyone?
Yeah, I have one doubt. Just, um, you have logged in with IIT Bombay, that DGX system.
Yep.
Okay. So
Yep.
actually, we have no, access of that.
Hmm.
So how can we then, we cannot understand how to log in there. So you are working your, PC with some command that ngc config set. So I
Yes,
cannot.
so this is like point is today is a kind of a demonstration session to you all. I know that you do not have access to the systems currently, right? But the objective is to make you understand how to run the jobs, because once you get the access, you can run this command seamlessly, right? So
Okay,
that's
okay.
why we are showing on your system only how to run everything, so that once you get the access, you do not face any issue from both Docker and Slum perspective.
Okay, 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 okay.
Okay.
Yeah, got your point. Okay, okay.
Yes.
Yes, you
So
can
I am
come.
I am not expecting you to like run this command parallelly, because I know you do not have the access to the system. But it's a demonstration from us to you, kind of a quick walkthrough how to run. And as a follow up, if you face any issues, then we and the MPCL team like will be there to help you for any in terms of running the jobs or anything for any issues you are facing. Okay. Once we have pulled the image from any other doubt, anyone?
Yeah, quick question. Does Docker previously we used to have access it with sudo, but now
Hmm.
don't seem to use sudo. So was it like
Yes.
because you logged in, sudo was
No,
not
no, no,
required?
no, no, no. No, that's the thing. I'm glad you asked the question. All right. So yesterday we were working on this system, right? And after before every command, we had to write sudo. Okay. So the resolution for that is you need to add your username. Okay. So for example, my user is there on your machine, Utkarsh. All right. It's not there currently, but let's suppose it's there, right? And you want, so there are few options, right? You might be aware that there is an option to add your user to a sudo group so that that user gets sudo privileges. Similarly is the case with the Docker, right? Docker is not something like a Docker sudo privilege, but it's like you can add a particular user to a Docker group, right? So what we did, we ran this command sudo user mode -ag. Docker is the group, okay, which is there on your system once the installation was done and all those things. And this is the username. Let's suppose your user there, so my user Utkarsh is there, right? I'll be able to run the Docker commands inside my user, but either through sudo if I have the sudo access. But then ideally what I have to do is I need to ask the admin to add my user to the Docker group. Okay, that's why I like we are not writing any sudo in front of the Docker commands, because we have added the DGX admin user to the Docker group
Yeah, so
using this command.
Docker is like kind of a user now. Docker is a user that has been added to the DGX admin group.
No, no, it's the opposite.
Opposite, sorry. DGX
Uh,
admin has been added
yes.
to the Docker group. Okay.
Yes, yes. So that the DGX admin can now run the Docker commands without any sudo access. The reason being, let's suppose I am a student, right? And I want to run, and I have my user, but my user, you cannot give the students admin rights, right? Or sudo access. So how will I run the Docker commands? Because I do not have the sudo access. Then you have to add those students, let's suppose me, to the Docker group. Okay, so the worry of adding giving me sudo access, it's basically you can say overcome by adding me to Docker group. Now I can run my Docker commands directly without any sudo privileges. Okay, I hope that answered the question, sir.
Yeah. Thanks.
Cool. The next step is your now what we are going to do is we are going to run this PyTorch image, which is 22.04. Okay, we are going. This is basically the tag. This is what we call a tag of an image. Okay, and this is your image name. So the command what we are going to run today is the Docker run command. Okay, Docker run, as the name suggests, what Docker run will do is Docker run will basically run your image. The usual format for Docker run is Docker run image name. Okay, so which is nvcr, just give me a second, nvcr.io, right? PyTorch and the tag. This is your usual format for the Docker run command. Docker run and the image name, and your container will be created. But there are a lot more flags that you need to set so that you can work very seamlessly, right? A few of those flags are, first is -it, which is for your interactive environment you want to create. Then the most important flag for you as an institute, it's a -p, which is for port forwarding, right? So let's suppose I'm a professor there and I have a research group, right? So using the admin, you can allot certain flags to my group, right? Similarly, to Bharat's group, certain ports can be opened, right? And those can be forwarded accordingly. Because else, if we do open every port, then it will be very difficult for admin and you as an organization to manage or to understand which ports are currently occupied or which of them are closed. Okay, so for that, what you need to do is, let's suppose what I'm doing today is I am forwarding my 1001 1001. It's actually the reverse. So I'm forwarding my 8888 inside the container and to 1001, right? And also I'm writing another thing, which is IPC equal to host. It allows all the shared namespaces which are there on the local in terms of the memory to be there on the container. Okay, and then you can allot the GPUs accordingly. Let's suppose I want to do the hyphen GPUs all. That also you can do, right? Now let's suppose you want to do the volume mount. You can do the same. Just give me a second. So wherever your mount is done in terms of the space, right? In terms of your whatever SSG or whatever your volume mount is, you need to mount that here, right? So I'm doing /home/DGX admin, that mount, and inside I've created a workspace. Just give me a second, and I can name it as IIT Bombay, right? And now at last your image flag is there, right? So we have added just a few more flags for convenience so that there is no issue when you run, right? And one of the most important flag which I missed is your hyphen name, right? It's very important to name the container so that you can properly identify whose container is running, and that person can be held accountable if they are using more than what is expected or whatever the case is, right? So what I do is I run this command.
Don't we need to create the container in user mode?
In user mode as in?
Like something hyphen new needs to be there.
I didn't get the question actually, sir.
Creating the container in user mode, I'm asking, so that nobody else can ask.
Yes, yes, you can use that. So currently we are just showing because we want to install everything inside this. So when you use hyphen u feature, yes, you will be. So currently, if Utkarsh will do ID here, so it will be root ID. But inside your
Okay.
when you use this, it will be your user ID. Welcome.
So one identity that you are there inside the container, you can see this username. From DG expert, we have gone to root ID, right? And the volume mount I have done is home DGX admin. Okay. One thing I wanted to show. Okay. The next step is before I show you is basically how to run a Jupyter lab on this, right? Because some depending on how you are doing, whether you
I
want
have
to
one
only run.
question.
Yes, sir. Go ahead.
So what is this IPC tag?
Sir, it's basically for all the shared namespaces which are there on the local in terms of the memory, right? Namespace provides the separation of all the name shared memory segments, semaphores, messages which are there on your container environment which you are running. That's the namespace. This IPC equal to host means, right? There are different flags for IPC equal to host. So then the next step is basically to run your Jupyter lab, right? So for that I'm running this command Jupyter lab hyphen IP 0.0.0.0. It means I can run from other IPs apart from the local host, which I'll show you what that means. Giving the root access which is there inside the container to the Jupyter lab. I'm setting the token as IIT Bombay and port to 8888. Okay, and please notice this 8888 I have forwarded to 1001. Okay, so I've run this Jupyter lab, and just remember one thing: the original image was the PyTorch image. We started from there. I'll repeat the process again. Okay, so now my Jupyter lab is running. Let's open the browser. So this is the Jupyter Lab interface. Please notice this is not Jupyter Notebook, it's Jupyter Lab, right? I'll write a token here. And you can see this is your container environment. We are already inside this. The advantage of this is the Jupyter lab will remain running inside the container, and you can see we have the container terminal available there, right? If you want to do any scripting, you can do from here. You can create text files. You have the TensorBoard feature available. You have the Jupyter notebook also available, right? This is the advantage of Jupyter lab. So one thing you will notice is that okay, in terms of the GPUs, okay, I had written hyphen GPUs equal to all. Okay, if I want to basically allocate only one GPU to the user or student, I can do by setting hyphen GPUs. Device equal to 0, 1, 2, whatever device I want to allocate to that student or faculty or whosoever wants the access. Here I had written hyphen GPUs equal to all, and you can see all the GPUs are available inside my container runtime environment. Right now, coming to the main point, why we need the containers. Okay, now the justification point will be there. You remember we haven't installed anything yet from PyTorch perspective or any libraries. If we do pip list, these are all the libraries which are pre-installed inside this container. Okay, all the libraries which you need. So Torch Vision, TensorBoard, Scikit-learn is there, right? Uh, all the libraries, you name the library and you will find this, which is related to your Tensor, this PyTorch container, right? So Torch Vision is there here, right? And let's search more libraries. Your Python is already there. Pillow is there. NumPy is there. NumPy is there. Okay, DALI is there. All the libraries which you need for your work to get started, it's already present inside this PyTorch container. Okay, so that's the advantage. And if there is any other library you want which is not there, right? I gave you the example of 1DB, right? So what you can do is you can do pip install 1DB and it will start running, start installing that. Okay, and then the next step or the last step is basically, let's suppose I want to save this container, it's running, and I also have some scripts here. It's lagging a bit. Is MPCL team, is anyone using this system? I feel so. Huh? Yeah, there's a lot of lag coming. Gaurav, are you there? Okay, let's start again. I try. So, if I do Docker PS, what's the meaning of Docker PS is it will list all the containers which are running. Okay, so what we have done is after Docker images, what we did was your Docker run, right? And here your image name and all the flags which you need accordingly. Now, if you want to come out of the container, what you need to do is I did Control P and Control R, right? So we are just came out of the container. We didn't exit or stop the container. We just came out of the container. It's still in the running space, a running phase. So Docker PS will list all the containers which are in the running phase, right? So that's the command for that. Let's suppose if I now want to stop this container, right? So for that, what I need to do is, sir, your someone's mic is open. Okay, so here you can basically what you can do is you can write Docker stop and your name of the container. So my name of the container is uu_itb, right? And I'll press enter and my container will be now stopping. Okay, if you want to stop a container, so it will take some time. Now my container is stopped. Now if I write the same command, which is your Docker PS, right? You'll see now there is no container present. But let's suppose you want to list all the containers, irrespective of whether they are stopped or started. These are all the containers which are present. So for example, this container we created 9 minutes ago and we exited 16 seconds ago, right? This ps-a will list all, right? A stands for all here, right? And now let's suppose I want to again start this container, right? You remember I've stopped this container. That's why the status is exited. It's not up. So I'll write Docker start and then again my container name. So if I now write Docker PS, you will see the container is done, is created 9 minutes ago, and now the status is up. Same thing will reflect in Docker PS-a. Now here, this container, its status is changed to up 13 seconds ago. But these containers, they were exited 21 hours ago, someone exited 2 days ago, and all these things can be basically here monitored by the admin. So I showed you the Docker PS-a, Docker start, Docker stop, right? So now I told you I have started the container, right? Let me clear it. I have started my container. So this is my container. So it's up 55 seconds ago. Okay. And I now want to go inside this or attach it. I detached by Control P, Control Q, right? So what I'll do is I'll give Docker attach and the name of the container. And now I'm inside my container environment. See, you are seeing root is there, right? And if I write exit here, it will not detach, it will stop. So if I write docker ps hyphen a, right, you will see this container was exited 6 seconds ago because I wrote exit here. I didn't write control. I didn't done control p control q. So this is for detach, basically coming out, and this is exit is for stopping the container. Okay, and then one command which we showed was docker attach, again the name of the container, again the name of the container, name of the container. Okay, now the next thing is, let's suppose I've installed OneDB, right? I want to commit it, correct? Basically what I mean by that is I want that from next time onwards, I'm not going to use the NVIDIA image, right? I'm going to use a new customized image which we have created using the base NVIDIA image and install the dependencies which we need for our use case specifically, right? For that, the command is docker commit, okay, container ID. So let's suppose we commit this container ID here, and then name whatever name you want. Okay, so let's name it as NVIDIA IITB, then this slash latest. This is the tag for that. Okay, and I'll press enter, and my image is created now. So if we go back to the stage one where we wrote Docker images, stay with me, where we wrote Docker images, you can see we have a new image 14 GB with our specific customization there, right? And from next time onwards, there is no need of doing Docker pull, Docker run of the NVIDIA image. You can run your own customized image with whatever flags you want. So I won't run any flag here. I simply write the image name and with the flag, and we are good to go. So we are inside the container and it has exited. Okay, so this is how you can basically create your own image, and for your purpose, if you want to use that moving forward, you can do that also. That's the advantage of using this. Okay, I'll stop these containers. Any doubts till this point? Any doubts? Anyone? No doubt. Okay, great. So now the next step is, hey, I have done everything. I have used my code. I just now want to remove my container altogether, right? Because it's taking unnecessary memory. So for example, what I mean by this is, in my Docker PS, there is no container running, right? But my container, if I do Docker PS hyphen A, my 6 containers are there which are there in the executed stage, and they're occupying unnecessary memory, right? So what to do? We need to remove this, right? So docker remove and your container ID, and your container will be removed. Okay, you can also write your container name if you want to. Docker remove uu underscore iitb. Okay, should be there. So fine. Yeah, there is no such container. If we want to remove this one, which we recently created, you can go docker, uh, again, same command, remove the name of the container, which is unruffled Jamison, and we are good to go. If now I run the same command, you'll see all the containers which I ran, they are not there on the system. So any doubts till this point, anyone? Anyone? No doubts? Okay, great. Uh, should we take a quick 2 to 4 minutes break? If it's like if you guys want it, then we can do it. So you can tell us. If not, we can continue in the chat. Yes or no, anyone?
Hello.
Yes,
So
yes, sir. Yes, sir.
one point is that so you have shown a lot of things step by step that how to run the that Docker and also that how to create the container, all these things. So I mean, basically, I have no idea, clear idea about these things. So I just want to say that if you can just run one Python file through whatever you have done, so I can understand it better, so I can
Okay.
feel them good.
Yep, sir. So the next step is basically we are going to run a job on this environment. What I
Okay.
mean by job is we are going to run a Python code for image
Yes.
classification for vision transformer model,
Okay, okay, then
VIT model. Okay,
okay. Yeah.
that's the thing. Anything else from anyone else?
Also, just want to add here, as you said, sir, here I have just posted a Slack link. You can join that Slack link. There, I will be posting one documentation as well. Whatever Utkarsh has explained, that will be covered in that documentation also. So that whenever you will get the access, or you can even install Docker into your own environment as well. That step is also written there. Please do not do it on DGX. It is already there, and you cannot do without sudo user as well. But on your own system, you can install Docker and try to run that as well. So that step, I will post it in the Slack channel. I would like you to request you to join the Slack channel, and I'll post in this hash workshop queries channel there itself. So you can later on after the session use the recording as well as the documentation which will provide to run the same things at your hand and do
Yeah,
your hands dirty.
yeah, yeah. Uh, Thank you.
Thank you.
Hello. Can we start? Can we get a quick confirmation once? Uh, is
Yes.
everyone back? Okay, great. So now what we are going to do is we are going to run a job. So we have three scripts today. One is your base code. The second is your optimized code, and third is your optimized code, but it will run on multi GPU. First two codes will run on single GPU. The last code will run on multiple GPUs. That's the code we are going to run. And we are going to show you the speed up in terms of the time that we are going to see leveraging these systems. Okay, so let's start quickly. The process will remain the same. Okay, what
Can
I
we
mean
ask a
by
can we ask a quick question before this?
yes, sir. Yes, sir.
Uh, we discussed on how to expose the port and then between the Docker and the host machine, how to get the applications running. What if we want to run something like a GUI where the X server has to basically exchange? Is it possible through Docker? Like a GUI application, basically, that is running inside the Docker could be coming outside the Docker.
So if your Docker container can run a GUI, so can you give one example? So few
We
of them
have,
are
yeah.
available with us.
Tensor board. Yep.
Yeah, no,
Yeah.
TensorBoard, Jupyter Lab, and all can be exposed with the ports. But I'm talking about
Yes.
something like we have in our medical imaging, we use softwares like QPath and all. We use to analyze the images, which is like we want to open inside inside a Docker container, but that is like a GUI. It's not exposed to any port. I'm not sure like it can be exposed to a port, but we generally run like a source command inside the in the terminal so that it'll open up the window. But just want to know, like, is it possible to exchange that from the?
I doubt it would be possible, but we can check that definitely. You can share with us the links and all, and as a query. Okay,
Yeah.
but we'll check it at turn. But why I doubt, because in this DGX server there is no screen available, so you have to do it on your own system and then connect to that system through maybe VPN, and then you have to do SSH, right? So I doubt whether it would come or not without any port, but let's see. You can share with us and we'll let you know. And
What about Clara?
yeah,
NVIDIA Clara, how is it?
yes.
Is it port based? You are launching the
Yes, it
application?
is port based, and there is a NVIDIA Monai as well. These two are the medical imaging based application. Both has annotators also with it. So yes, if you can use them and they are port based, so you would be able to do that on the
Okay.
GPUs. Yes.
Anyone else? You can ask the question while I'm preparing the environment. Any other doubts? Okay, cool. So what I'm doing is same thing I did. I ran your container for PyTorch, right? And inside this, what I did, I installed GDown. It's basically for Google download, right? And now I had my code base and data inside this zip file. I'm going to unzip this file and all my models, the different PyTorch models which are trained, saved, right, and the data set, it will all be downloaded and unzipped. That's what I'm doing here right now. Okay. So now let's suppose if I go to this folder which I've created, SGP. Inside SGP we have train folder which has our code base. The advantage of Jupyter Lab is you can use this basically for navigation purposes also. These are the scripts which I'm going to run, right? And as a requirement, I need to install 3 libraries which are not there on this container. One of them is WarnDB. What is WarnDB is basically it's a kind of a logging and monitoring kind of library, right? Weight and biases we call it, where you want to zoom it. Okay, is it better? Cool. I'll try zooming this one also. Okay, so now all these three libraries are installed. So now what I'll explain very quickly because what I really want to show is how to run the script, right? In a separate session, separate workshops that we have, we'll be covering the optimization and what we are doing in much more detail, right? So we have three YAML file. One is base, which is one GPU without an optimization, right? So here there are different configurations which we have set. Second is your GPU optim. So this is again which will run on one GPU. Then we have parallel.yaml. Okay, so this will run on your 8 GPUs parallelly, right? And inside this code, I'm setting the word size as 8. So this code I had prepared to run on 4 GPUs, but in this system there are 8 GPUs. So I'll modify my code accordingly for 8 GPUs, right? So inside main.py, first I'll be going to run this base.yaml, right? And to run base.yaml, what I need to do is please do not think that this thing is different. For example, torch, I'll run using torch run main.py. You can run using python also. It's just that I've added a few dependencies which are there in the updated version of torch run for multi gpu, right? So I'm adding my 1db here. Just give me a second, and let's stop this once. Here you can add the configuration. So I've already created the IIT Bombay in my account, but let's change the configuration to nv slash hyphen underscore IIT Bombay, and I'll store this here. And now I press clear here, and I'll run the same command torch run main.py. Now enter your choice. Now here I want to add the API. Okay, uh, but here I won't be adding the ngc API. I'll be adding my 1db API. For 1db API, I need to go to settings. I need to go to this API key. I'll copy this API key and I'll run it here. Pasted it here, pressed enter, right? And you can see my API key is being appended to the netrc, and my username, which is upal. You can see it's running under that umbrella for upal, right? And it's downloading the data currently. So there are two types of data sets we are leveraging for this. And now it's basically, it will download the VIT model. And now it will start training. Please notice this is running on single GPU, right? And without any optimizations. So if I do watch NVIDIA SMI, right? So you'll notice only one GPU is being occupied, about 20 GB is being occupied currently on 128 batch size. Let's do a thing. Okay, what we're going to do is we'll be going to change this base.yaml and increase the batch size more, right? Let's utilize our GPU to the maximum. So we'll change it to 512. Let's see how much memory they occupy. I'll run the same command, and parallelly you will notice on my Google Chrome, if I go to 1db slash AI, and you can see this nv underscore IIT Bombay is being created, right? This I created a few hours ago on my V100, just to show you the demo in terms of the numbers. Okay, sorry for that. Yes. So if I go back to this, you can see this is running, right? And the amount of memory it's taking, it's 74 GB of GPU memory. And the utilization is not very consistent. It's up, down, spiky utilization, right? So this is your code which is running without an optimizations on your single GPU, right? And already it's like 1/5 is done, and it's already taken about, you can say, 43 seconds. So it will take in the ballpark of like around 5 to 6 minutes to complete one training epoch. Okay. So let's wait for it to complete. Then the second code that I'm going to run, it's basically your GPU underscore optim. So I'll comment it out. This one I'll comment out, and I'll comment it in. Okay, so now it will take my optimization code, but it will again run on a single GPU. So in optimizations, what I've done, I've improved, I've done certain kind of data loading based optimization, and I've also used automatic mixed precision based training, right? So you can see half of the training is almost done. It has taken about 1 minute 30 seconds till now for my half training to be completed. We can see our logs here also parallel if we want to. Okay, just give me a second. So it has already taken 1 minute 50 seconds. So this was which I already stopped. So I'll delete this run. So it's currently running. This one is in running state. And let's see. We are waiting for it to get completed. Any doubts till this point? Anyone? What's inside the code, all that it was out of the scope of this session, but we are going to discuss in the 4 or 5 day workshop that we are going to have on computer vision, NLP and speech. We'll be discussing all this in much more detail with the workloads and all that. This is just for demo purpose, how to run the code and inside the container, and to show you, right? So you can see it has taken about 2 minutes 41 seconds for training of one epoch. Okay, I'll kill this code, and please notice it took about I think 74 GB in the ballpark of that. Right now, what we are going to do is we are going to run the same command, but please notice we have changed the configuration from base to GPU optim. Okay, so what I mean by that is here you can see my selected data loader is optimized. Okay, and what you will notice is my training will be very fast. Okay, very fast means and also much more optimized. Okay, let's check if I change the batch size. Oh, I forgot to change the batch size to 5212 to have fair comparison. So this has taken 3 minutes here, right? For the first, which we already seen, right? And now you can see this one is occupying 54 GB. All the parameters are same in terms of memory and all that. It's because we have applied automatic mix precision. So now my precision, its training is happening on both FP32 and FP16. Okay, and you can see your training is considerably faster, right? Now the last code till the time it finishes one epoch is your DDP code. So here I'll be leveraging all the GPUs for me. Okay. For my purpose here. Okay, and let's go back to that. So it's almost done. About a minute it has taken. Uh, so it completed in 1 minute and 8 seconds, the training thing. There it was about 2.5 minutes, right? So let's stop this again. Now the last thing is showing you the power of multi-GPU training with the optimizations. For that, we'll be running the code on your 8 GPUs which we have, right? And the command we are going to run, it's basically the this command for torch run, right? And we are going to run on 8 GPUs, right? Uh, the what we'll be doing is we are going to run on 8 GPUs. Okay. Yes. So number of processes per number of processes plus here it will be 8, right? I press you can see now everything will be printed, right? Because my processes are there on rank 0, 1, 2, 3, 4, 5, 6, 7, right? And then you can see the now let's wait for some time. Let's see the bar, right? 8 seconds we have completed the entire thing. My all the GPUs are occupied to the maximum, right? 100% utilization is done. And the speed up you can see, like within 8 seconds we are able to complete the entire one iteration initially. So from 3 minutes, which is about 180 seconds, we have changed to 8 seconds, right? So roughly in the ballpark of 25x is the speed up from your without optimized code to multi-optimal code. Uh, any doubts, Bharat? You can address them. Yep.
So Utkarsh has hard stop right now. So I'll be taking care for the next part of the session. So you'll let me know if you have any doubts. I'll be starting with then the Slurm session and how we have utilized another container runtime, just like Docker, to run the jobs in Slurm. So I'll be covering that part. Before that, if you have any question related to NGC, Docker, and you can say DGX, you can ask me. So I have posted a Slack channel link in the chat. There itself, I have posted um, one of the documentation page as well, where all this documentation related to login into NGC and then installing the Docker into your environment is available, and then finally running any workloads. For example, I have mentioned there how to run a fashion MNest workload which is present already at NGC, means all the code and models are present at NGC and the container. So how to run it with TensorFlow container, I have posted that in that documentation. You can follow that for a quick hands-on. Okay, it's not necessary you use models and um, code from NGC only. You can take the code from X hub to and use the NGC container to run that. It will work as similar as you are running it with your Conda environment or uh, virtual environments. So any question related to that, or I should move forward? I currently only 12 people have joined the general channel and 4 the workshop queries channel. Please, I request all of you to join that, and which is present in my Teams chat. The Slack channel is present. You can join by clicking on that. If any issue you are facing, let me know. Thank you. Okay, so let me share my screen. These all. So I am also going to post uh, these two links, which is PyTorch and TensorFlow optimization links. So here you will see the guidelines of how to optimize your code for the GPUs and CPUs in an optimal fashion. Okay, for example, if you want to take right now Utkarsh has showed one PyTorch code, right? There he showed 3 versions of it. One was simple uh, PyTorch running on the GPUs, which was not utilizing the or which was not utilizing all the cores, right? So I would request you to follow some of the guidelines mentioned here. You would be able to see that now your PyTorch code will run almost 2x to 3x faster on the same GPU. Okay, and will utilize the full power of the GPU accordingly. Same way, there is some multi GPU, multi node, you can say, suggestions also available how to do that part. So with the help of DDP, so that also you can find out here and run it, which Utkarsh also utilized from here itself, and run it on its PyTorch environment, where you are all able to see that he was running it on 8 GPUs, right? And which took only 8 seconds to run the one epoch. So that way you will be also able to run your large workloads like medical imaging, NLP based applications, right? So let me see if there is any question in the chat. Yes, I am posting. So this is Slack channel only. And here I'm posting the links on the Slack. I request all of you to join there so that every other link, for example, this NGC documentation also have posted here. You can see from the start, if you want to install on your own system, which has GPU available. For example, you might have a GTX based system available, right? GTX GPU based. You can install you can install Docker there and start running your application. Okay, you just have to again do you don't have to again enable NGC there because you have already signed in. But yes, you have to use NGC config set to set up your environment. And to do that, you can follow these steps. And the demo is also available for one of the application, which is a fashion MNS dataset I used from NG. The dataset is available online, which you already might know. Here from NGC, I took the container model and pre-trained model, and one of the resources like Jupyter Notebook was available. So I used that to run it. Here some blogs and recordings are also available. You can follow that from here as well. Thank you. So now let's move with the Slum session. Okay. Let me know if you have any question in between. Okay. I might not be able to see sometimes in between the Teams channel. If you have any question, you can unmute yourself and ask the question. So I'm Bharat Kidwani. I work as a data scientist, deep learning here at NVIDIA. So I would be mainly talking about the simple and unprivileged GPU resource sharing tool by NVIDIA called as Enroute, and its Slurm integration called as Spikesys today. Okay, how you can use these NGC containers. NGC is like a repository where containers, models, resources, collections are present. Okay, resources means just think about like Python codes are present. Okay, for you to run, just like a GitHub. Okay, so there everything is present. Now, if you want to use NVIDIA containers, which are nothing but the GPU optimized um, libraries, okay, installed in it. If you want to use them and run them with Slurm in the Slurm cluster, how would you do that? Okay, with their Docker will fail. You won't be able to do with Docker. And now you have to utilize something called as Enroute to do that. So Enroute I'll be talking about in the later couple of slides. Before that, let's see our agenda. Let's see the agenda for today's topic. Okay. So first of all, I'll give you a brief again about uh, NVIDIA container runtime, which I think Utkarsh has not covered, but he has covered the NGC part. So I'll be talking about what is NVIDIA Container Toolkit. Then we'll move to Enroute and why should we adopt it. And then we will see how you can use this in Slurm type of uh, scheduler for your applications like PyTorch or TensorFlow and so on. Okay. Then we'll share some of the you can say important links at the end to call the action. Okay, NVIDIA Container Runtime. Okay, NVIDIA Container Runtime is actually a 14. So before moving to NVIDIA Container Runtime, before moving to that, I would just like to introduce to you to all to NVIDIA's work in different domain, so that Very quickly you will be able to understand why it is important. Okay, very quickly I'll just cover it. Here you can see Nvidia used to be a uh, hardware company only, right? So we used to create only hardwares with GPUs, mainly GPUs as the main processor. Here you can see we are in the graphics domain where gaming and all is the culture. Gaming visualization, you must have heard about RTX 3090, 3080s just launched, right? So we are there. You can even run deep learning examples, but it is not recommended to use that GPU to do deep learning, but people run that as well. So RTX is mainly for visualization and gaming. We are into DGX for AR VR if you want to do AR VR. So you can do that as well in GPUs. The specific GPUs are available for that. Same with AI and data analytics. You can see DGX are the DGX GPUs are the main ideal platform for you to run the end-to-end uh, deep learning. And Utkarsh has already explained why it's so. Okay, now here you can see we are also into medical and genomic sector specifically when it comes to the deployment at hospitals. Okay, so if you want a edge device to be there at hospital, so you can use NVIDIA's Clara Holoscone type of machines, which is an EGX based machine. Okay, same with 5G and RAN also, it uses EGX based architectures. Similar to that, we have partnered with Mercedes. So up in upcoming soon in upcoming Mercedes cars, you would be able to see self-driving cars are available. Self-driving features are available in their cars, and they are based on NVIDIA AGX architecture that are nothing but edge computing based architectures, embedded architectures like Jetson. Okay, same we are into the domain of robotics as well, and here also hardware called as Jetson are heavily utilized by all of the companies, startups, and industry HERs for uh, creating their embedded solutions. Okay, fast and accelerated embedded solutions, which are AI accelerated. And we have created software stacks as well, our own software stack to run them on GPUs. Okay, so those all things are mentioned actually in this particular slide. You can see we are not just now the hardware company. On top of it, we are an end-to-end accelerated company starting from hardware to the use case. Okay, to the framework, application framework end. Okay, so at the bottom you can see these are some of the, I'll quickly cover, I won't go into deeper of it. So these are the some of the libraries or things which people use to do uh, to run vGPU, vCPU kind of virtual GPU kind of applications. If you want to use that, you can also do that with NVIDIA. And here on top of that, there are the support of CUDA, Docker, and core hardware level libraries, which allows you to interact with your GPU and networking. So we are not just doing the GPU part, we are also creating the networking and uh, CPUs will also come in upcoming releases. So you would be able to see the libraries, hardware level libraries will also come for the CPU. Same with a GPU is already available. You already know called as CUDA, and Docker is for networking and DPU communication. Okay, now on top of it, we have machine learning libraries called as machine learning library called as Rapids, which allow you to do uh, d- data frame processing just like pandas, uh, machine learning processing just like scikit-learn on GPUs. Okay, the same way deep learning libraries, we are integrating with many frameworks like TensorFlow, PyTorch, MXNet, all has support of cuDNN, TensorRT, and Cutlass to do the matrix multiplication and deep learning operations into these frameworks. Okay, so same with HPC and visualization side as well. Okay, on top of it, we are created some of the application based frameworks as well. For example, Riva for speech processing. If you are doing the speech AI or NLP, you want to deploy that in an industry setting, you can use Riva. Same with DeepStream. If you want to deploy a video analytics use case, you can do with DeepStream. There are many such. Same one of you mentioned Clara as well, and it is also a library for uh, eff- for efficient deployment and training of medical imaging and healthcare related tasks. Same for other domains are also available. So that was the quick overview again. And now let's come to back to our NVIDIA Container Toolkit. Okay, so what is NVIDIA Container Toolkit? So you used Docker just now, right? So on NVIDIA GPUs. So uh, so how Docker was able to use the GPUs? There was the CUDA support involved in those GPUs with the help of a library called as NVIDIA Container Toolkit. So we provided the support for all the major container runtimes, uh, which for running CUDA related CUDA applications like PyTorch, TensorFlow, and inside applications, whatever you are running. Okay, so by all container runtime, I mean all, not just Docker. We have given this support, NVIDIA Container Toolkit support to all other container runtimes like Singularity, Podman, Enroute, and so on. Okay, so this is major installation you need to do before installing any container runtime like Docker. Okay, otherwise you won't be able to utilize the GPU. Okay, so that means if you are using Docker, you have to first install container runtime. And in the link which I have provided in the Slack channel, there itself, first, if prerequisites are not present, you have to there itself it is written that you have to install NVIDIA Container Runtime to run the containers on the GPUs. Okay, using Docker. So this is what NGC catalog contains: containers, pre-trained models, frameworks, and so on, which already been covered. Now let's see why Enroute. Okay, why not Docker? What means, what is the benefit of Enroute over Docker in while we are using the Slurm environment? Okay. Sorry, till now, if you have any questions, please let me know.
Can you just tell me, I mean, that NVIDIA Enroute, so it is a, I mean, if we have some code that is not directly, we can employ or apply through the container part. So is it, I mean, for that reason, we need that Enroute path or NVIDIA Enroute?
No. So can you tell me, give me an example which you cannot run on the containers?
No, actually, suppose I have some GitHub code, okay,
Okay.
and those library are not compatible with the container or Docker, whatever the original library out there. So suppose PyTorch, some versions are there, but in the GitHub code, the versions are different.
So
So
let me just, before moving to that, I'll just share with you this link. This is a framework support matrix link available with us. Okay. So here it is nothing but it is explaining which version of PyTorch is available in this particular container image and in this image. So if you go to your NGC page again, right? Let me just continue with guest for now. Okay. So here, if you go the PyTorch image, let's assume, no? Then there are multiple PyTorch images actually. You
yes,
have to go to the containers only to search PyTorch. Okay, so here when you go to the page, here it's something is written like tags. Okay, tag defines which version of PyTorch you want. Okay, let's assume if I use 22.04. So you just have to go to the framework support matrix, see which version in 22.04, which is means year 2022 and month 04, there which version of CUDA is available, which version of cuDNN is available, and so on and so on, which version of PyTorch is available. Currently it is 1.12. So if you want older version of it, so we are using NGC from 19 I mean 2019. Okay, so whatever versions from 2019, those all are available here. If you feel I want even before version of PyTorch, you can uninstall that version of PyTorch inside the container and reinstall the PyTorch using pip install torch and then version mentioning of that. You would be able to do that inside the container. So I won't see there will be a challenge. But even if you feel there is a challenge, there's one more good feature of containers. Inside the containers, you can create a virtual environment.
Okay, okay, yeah.
Okay, so
Okay.
if you even feel, I'm not able to get the proper libraries by using pip uninstall or install, you can create a virtual environment inside the Docker as well.
Okay.
And that would work. That answer. Okay, so this link is also, I'm just sharing here. Later on, I'll share on the Slack as well. Oh, sorry. So there are other benefits of en route actually, which are not being covered in Docker. So actually, these are the kind of issues. Now, first of all, there are lots of flags you need to mention. Other thing is there might be a slight security issue with Docker. I'm not saying the whole thing is secure. It is not secured, but sometimes you would kind of being a root user inside that, so might be a little bit worry about that. So with nroot, you can set yourself as a root or non-root user depending upon the requirement, uh, based on your you can say priorities. Okay, so which your admins or you would be your admin or your professor can uh, uh, access. Okay, or you can say give permissions to. So here usability is very much better compared to the Docker. Means I'll explain you the en route part. Their usability is also very good. And third thing is in the Docker, you cannot integrate Docker with the Slurm because with Slurm, when you use when you use when user will come, right? There are multiple users can be there, right? So as C groups inside Slurm, C groups will provide the limited resources to each user. Okay, sorry, and proper amount of CPU, GPU, RAM will be provided to that. Whereas if you use Docker inside Slum, that C group isolation will get lost, and you will be able to you will not be able to uh, uh, do the proper isolation with each of you. Okay, then you have to manually mention which how much amount of GPU, how much amount of CPU and all would be required for me. So those kind of issues were there. Okay, so so and also in HPC like environment where multiple systems are available, um, in your case where 5 to 9 DGXs are available. I'm not sure whether you will be clubbing all the 9 GPUs together or you'll be dividing them. But in a large cluster like this, you might require the usage of multi GPU and multi node trainings, right? So in case of Docker, you won't be able to do it as efficiently as you would be able to do it in Slurm. So there again, you would require uh, NGC or container support, right? Where all the applications are all means all the libraries are already present. You just have to use them for your code, okay, and schedule it on the environment. So Docker was unable to do that, was unable to use the Mellanox feature, which is doing the multi-node uh, training feature. So Slurm came into that picture, and in that case, and there was no integration of Slurm with Docker. So we came up with idea, let's use something else. So there are multiple other options available. So here in this case, you can see these are the few alternatives available of Docker. So here 5 types of already existing container runtimes are available, which has the integration of NVIDIA Container Toolkit already, okay, to run the GPU based containers. But options like LXC, okay. So in LXC there was no support. Uh, there was no support of Slurm actually. So again, just like Docker, you cannot use LXC to run on the Slurm. So that's we discarded by default, and also it has very weak isolation, just like uh, Docker, okay, and has low overhead. So you wouldn't be able to use LXC in a in HPC like environment, but it is very good for cloud native environment where just the deployment is the main task. Okay, same with Podman. There is again no integration with Slurm, but it is really good in using this in using you can say GPU optimized containers on cloud. If you want, so many cloud providers use Podman, and many who wants to deploy their application in a cloud native environment, just like Kubernetes and all, they also use Podman or Docker. But Singularity was really good when it comes to HPC deployment. So Singularity is one of the container runtime which one can use to run the HPC containers or HPC applications. Uh, just a second. Sorry. So here, what I was saying, so Singularity is good. You can use this for a Slurm type of workload, and many of our applications are also supported here. But this is not much optimized for deep learning type of containers. There are some bottlenecks in management of those containers in management interface side of it. So again, this was some of this had some issues with it. So same with Charlie Cloud. Charlie Cloud again has no integration with Slum, so we have not used it. But yes, it is mostly for the cloud native only. So many of that are had cloud integration, but has very weak isolation and multi-tenancy features. Whereas Singularity had one, but it again had some kind of issues related to management. So we thought of creating our own runtime, container runtime, which will cater all of these features. Okay, high performance. Sometimes Docker images are not so much I would say it is. I would say it is slightly less performant than en route, not much, but yes, en route images utilizes every like the the Docker run type of command itself on the GPUs. Okay, so running the commands also is fast in en route, and they also they also has very good integration. I won't say it's a big factor, it's a very minute factor, uh, but that was one which we uh, enabled in en route, which I'll talk about later. Support of Docker images. So most of the places like Docker Hub, NGC, all of these uses Docker as a main runtime, right? So you have seen in the NGC page itself, there were commands written for only NGC. There were commands written for only Docker, right? There were no commands for Singularity, Podman, or let me just open it here. There were no commands for uh, enroute or anything else, right? Only Docker commands are present. So because it started with Docker and all these and Docker is really famous, like most famous library, container runtime library to run the containers, right? At every place, even in Docker Hub, even in other repositories, you would be able to see Docker is used efficiently and most uh, high in most huge amount, right? So what we have thought, let's provide a support of Docker images through another container runtime. So every other Docker image from any place can be run through NVIDIA's en route uh, just by changing the command. Okay, the syntax of the command. It has multi-tenancy feature in the soft clusters to run larger workloads in that architecture. It has the supports of NVIDIA GPUs, Mellanox, so that you can do multi-GPU and multi-node training. Here, resources will be isolated, means you can manage that manage the amount of resources to be given to particular user in Slum with Enroute. Same way, multi-node jobs can be submitted very easily without much of the hustle. It has the MPI support, all those things are available into it. Okay. Now supporting development of interactive jobs can be launched with it very easily. Uh, and also job type of things also uh, can be run very easily. So with interactive job, I mean, so sometimes in slums you won't be able to create the Jupyter notebooks and run the interactive jobs, right? Sometimes, but in this case, you would be able to do with the containers. So no existing container runtime fulfill all our requirements. So we created enroute. This is a rootless, I would say, as unprivileged runtime called as enroute. So that's why it's named like enroute, because it's an unprivileged uh, rootless you can say container runtime which can uh, um, which can run your containers from
What
the
do you
Docker.
mean by hi hi? What do you mean by rootless or unprivileged? This means
So
this doesn't work as a sudo.
yes, inside the container, you can it is up to you. You can before setting up the environment, you can manage whether you want users to be inside the container with user with root or without root, means with their own username or not. And even
Okay.
after that, you would be able to install the libraries through pip. So there won't be an issue with that.
Which
Okay,
provides
clear.
more, which provides more isolation, Docker or Enroute? Because it seems
And
like Enroute is providing more isolation.
yes, yes.
Okay, I see. But the Docker, there is a complete isolation in terms of port and all, right? Because port needs to be exposed. But here in Enroute, it seems to be like the C groups are shared, namespace is also shared. So is there a the isolation is less in case of Enroute? I felt like that.
So, so that is only isolation is right. Means
Right.
you are able to distribute the proper amount of. Otherwise,
Yeah.
I
So
don't want to
okay.
say.
Uh,
Yeah. With Enroute, you would be able to distribute properly. It's up to you if you want all of it.
yeah.
That also can be done with Enroute. If you want the particular amount of it, which Slum by default does for its users, whenever you are launching a slum with module load, you would see that you will get a proper amount of the a specific amount of the you can say uh, resources, right? But with Docker, if you use Docker with Slum, you won't be able to get that. It means you one user can take all the resources as well with Docker, but
Docker
that
can be
won't be required.
orchestrated, right? Docker can be orchestrated to make the resources allocated.
So to do the orchestration, you have to apply Kubernetes, you mean, right?
Okay, I see. So, but then resource allocation can be done in Docker, but it is complex.
Yes, means if you want a resource allocation type of feature with proper amount of orchestration, you have to use another layer just
Like
called as Kubernetes.
Kubernetes. Okay.
So here in this case, we are using Slurm, which is a scheduler. Same way, you can use a orchestrator to use it with your Dockers. Okay, which is a Kubernetes type of environment. But if you feel it is required, let our partners know, they would be able to do it. I would
Yeah.
request you to
Yeah. So
start with Docker for few days or months. If you feel no, we would require some kind of isolation even after that. On top of Docker, you can go with Kubernetes, or you can use the Slum plus Enroute feature. So
Yeah,
simply, yeah.
I had a doubt because let's say someone is running a container inside the host machine, and the host machines the resources are shared between the Docker and the host machine. So the isolation in case of en route is like the same user who is logged into the en route is also using the same resources as the host machine user who is logged in is also using.
So in Docker, one can use the same machine. The same GPU can be used by multiple people. Okay.
Yeah.
Whereas if you use Slurm, you will get your proper resources because your job will take away those resources, right? So others
I see.
cannot use it
And the
until your
port,
job
yeah,
is done.
yeah. So in
And
Docker also we expose the port less. We specify to expose the port, but in root ports are all exposed by default.
yes,
So that provides less isolation, right?
there also you can manage to. So
I
if
see.
you require that, there also you can add that you would every user will get this much amount of port. So that thing can be managed there as well.
Okay.
And in the Slurm environment, I would say people generally follow only the bash commands. Okay, they mainly do the scripts running. They don't much require the ports and all to work, right? Means they don't require Jupyter notebooks mostly. They do multi GPU, multi node training. Uh, just using the bash commands. So I would be showing that only here in this case. But if you want the port to be there, you want the interactive environment, and so that can be enabled in the Slurm cluster. How much ports each user should get. So like for example, every user can get 3 ports, 4 ports. That kind of thing can be done here as well. And in Docker, why it is not you can say why it is less isolated, you can enable any port, right? Means inside inside the Docker. So if it is if a port is stopped, so for all the user it will be stopped. Okay, so you would be able to and you will not be able to see which ports are occupied. All those things might come in between, but uh, if you properly manage that these 3 ports will be for um, these 3 users, some kind of thing you already create internally, then you won't face any issue even with Docker. But in enroute, you can explicitly set, not in enroute, in Slurm, you can explicitly set that each user should get this ports.
Thank you.
So here in enroute, I was saying it can utilize Docker images, means images which are built using Docker directly with its environment. Okay, so we have not explicitly created the images using enroute. We are just utilizing the images which are already built through Docker because in the public open era, everywhere you will find Docker images only, right? So even if you don't want to use NGC, you want to work with Docker Hub, you can use that images also from that place and use it with the enroute. So Utkarsh explained you a command like called as Docker pull, right? So where he was pulling the image from NGC using Docker. Okay. So pulling in the sense if you use Docker pull, so it will take the image from the NGC and store it in the in the Docker repository, which is present at in your machine. So in that, you would be able to see it using Docker images, right? Same way, Enroute can also pull images uh, from NGC or any other hub using this command. Enroute import. Then here you need to just write Docker // nvcrio, and this is the image name. The same image name that he used, I would be also using in my experiment. So let me just do it in the code directly. Let me just connect to the session. So he used this image, right? nvcr.io, which is nothing but NVIDIA container repository. And inside that NVIDIA, this is the usual structure of all the images which is present at NVIDIA NGC page. Just the tag will change and the name of the image will change. Okay, here. So it is available in my Docker images. Same way, I'll pull a image using enroute from my enroute import command. Okay, so let me just open NGC page again. So you have to log in with NVIDIA account because you have not, you don't have the SSO. Achha, let's just go here only. So my image name has 22. My image name, when you click on this, right? So it will copy an image in this format, nvcr.io/nvidia/python, then tag name. Okay, I'm just copying it here for now. Okay. So here, this is the image, right? But in case of enroute, let me just open the enroute page as well. Okay, enroute GitHub. You can find it in our, oh, sorry, enroute GitHub. Okay, so this is our repository where enroute is present. Here, this is, you can see everything is written here, a simple yet powerful tool to run containers. Here in the usage section, let's see how to use it efficiently. Here you can see the commands are written, right? The same commands which I mentioned in the Slack channel. So here you can see user ID is also mentioned, which is nothing but my Docker user ID. Okay, which I used using Docker login. So it is good if you do the Docker login first. So means enroute works in parallel uh, with your Docker. Okay, it's not we are discarding the Docker entirely. Just that we are using some of the features from Docker and we have added few of it on top of it, so that in the Slurm kind of environment or the environment where isolation is required. I'm not saying only at Slurm you would be able to use enroute, but you would be able to provide more isolation. You would be able to provide rootless feature to your containers through enroute. Okay. So here, once the login is done, okay, it will ask for auth token, username, and the API key, which I have already, Utkarsh has already done that. So I'm not doing it again. So once done, you can use the image simply like this. Okay. So here it is taking the CUDA image. I'll change it to PyTorch image. Sorry, my other thing is running parallel. Okay. So we have already logged in, so you don't need this auth token. You can remove it. Here, when you are writing the container name, right? Just one more thing you need to change is apply a hash here instead of slash. Just a second, I'll getting a message call. Okay, thank you. So here in this case, you can see nvcr.io we have written. After that, instead of slash, you have to write hash. This is the only change you have to do in writing your image name. Okay, from NGC. So you can see this is the same image name which I copied from NGC, right? From here. Okay, where is my NGC page gone? Okay, here.
There are moving buses, all those things, the action model. We just create a sort of.
So when you, so it is the same format of image name, except that here we have just changed it to hash. Rest everything is same. Okay, so let's come back, and when you let's install some other version of it, because I have already installed one 22.04 in my environment. So when you use this, the 22.05 tag of PyTorch will start downloading in your environment. It will save itself in a in your local machine. Okay, it's not like Docker images. It will save in your current directory. Okay, so you all can create your or pull your images using Docker and save it in your environment. Okay, in your in your own directory. So that way, all of your images will be uh, available for yourself as only. So let's let it happen. Till then, if you have any question, you can ask. I'll share this link till then in the Slack channel.
I hope you.
Okay. Root. GitHub. Here, mainly you would require to learn a bit about the usage part. Okay. So enroute import, enroute create, enroute start. This is when you don't have the Slurm environment. If you want on your own laptop, you want to use enroute, you can use these commands. Whereas when you use Slurm, you won't require these 3-4 commands. You just need enroute import, and then your Slurm will be able to create and start the environment using a hook called as Pixis. Okay. So Pixis is specifically for Slurm. So whenever Slurm workload manager is present, Pixis would be able to launch your containers using enroute into it. Okay, so Pixis will require enroute to run the containers you in your Slurm environment. Whereas enroute is not Slurm dependent, it can use as it is like Docker you are using, you can use enroute to create, run your workloads. Whereas Pixis will also add up as it is integratable with Slurm. So with Pixis, you would be able to launch MPI runs, means you would be able to launch multi-node runs, multi-GPU runs as well. Okay. This is the usage in Slurm, how you can use a container inside a Slurm is available using srun command. Okay, I'll show that as well in our demo. Let it happen. Okay, now you can see your image is now downloaded. Actually, let me just do ls here. Here you can see a sqsh file is present, right? So this is your um, image which you have pulled using enroute import command from ngc. Now you just have to provide the path to this image in your srun command, and you are good to launch a container with for this. But you are good to launch this container with srun. Okay, so let me. I'm not going to use this. I have already set up one environment for one of the image because the code requires that particular version. Otherwise, it might fail. Okay, sorry. /DGX admin. Okay, so in my RAID, I already have two SQSH images available with me. Okay, one is a PyTorch, another is a Nemo image. Nemo is our library. So I'll be using this, which Utkarsh also used, but with enroute and slum. Okay, so let me run the srun command. Just a sec. Okay, so this is my command. So you must be knowing about srun. So srun will launch the commands in your environment, right? Srun will launch a job in your uh, uh, Slum environment, right? So before that, let's see how many machine nodes are available here. So currently in this particular machine, one node is available, which is a DGX node. So it has total 8 GPUs available in this complete node. So all this 8 GPUs are available into it. Okay. So let me and now let's let's run the srun command again. So currently nothing is running. To check that, you can use sq command, and here you can see nothing is running. When we launch srun, sorry. Okay, when you use srun command, here you just have to provide a flag called as container image. Okay, earlier if uh, it was not available with Slurm, but when you install Pixis, which MPCL team has already installed, so when you install Pixis, you will get these additional flags into your srun command. Okay, when you write srun help, these additional flags, container related flags will come up. Okay, in this flags you would be able to provide the container image name, means which image, the path of the image name, or you can simply provide the uh, so you even don't need to do en route import. Okay, you can even provide the image name which you provided in en route import. Slurm will automatically pull that as well from NGC. Okay, either you provide the path of the SQSH file. Okay, this SQSH file which I have provided, which is present in /red/dgx admin, and then the path of this image, or simply provide the image name which will automatically pull from NGC. Okay, so here let me just, and here again let's go back to our page here. Here few more flags are present called as container mounts, container work directory. So all these you can set which were available in Docker as well. Okay, so you remember you can mount the directory from source to destination, right? So that is also available here. So you can save the container as well. You can save by default mount as well, means you can simply mount your home directory by default with this flag, and there are few more flags also available which you can use to do other type things, right? Which you can do used for few more isolation. So I'll be using container image and provide the path directly. If you don't want to use this, you can simply also use NVIDIA nvcr.io hash NVIDIA /pytorch colon 22.04 hyphen py3 also, and it will pull the image. And you here I have provided hyphen container mount home, which means it will automatically mount the home directory inside the container. Okay, my home directory is /home/dgx admin. It will mount that inside my image. Okay, now here you can provide how many number of GPUs you want. Okay, and that thing you can set for a particular user also. Okay, that one user can take only two GPUs or one GPU, but right now it is available all GPUs for me, so I am taking all 8 GPUs. You can provide other flags as well. So for example, exclusive flag, this will allocate all the resources which is available for a particular user. Okay, currently we have not pro- provided the proper number of resources for each user, but currently for me, my case, all the I can take all the resources. So here hyphen exclusive I am writing, but we will but depending upon the environment you want, we will exclusively define the resources for each user. So accordingly, he would be able to. For example, it has 256 cores. Sorry, 128 cores. Let's assume if you write exclusive, currently all the cores will be allocated to me. But when we define the number of cores for each user, so he would be only able to take at that limit only 32 for each user or so. Okay, example I'm taking. Same way, you have to provide the partition name, which is hyphen p flag. The partition name you can get through sinfo. So in this case, only one node is there which has the partition name as GPU. So I'm using that. So, okay. So now the final thing is after SRun, you can either go into the interactive environment or just launch your command. Okay, and it will run and stop. But I'm going to run a interactive environment into it. So using hyphen PTI, I'd be inside the image. I'll be inside the container image very soon. Okay, it will take some time because it is creating the image using SQSH file. It is actually in the backend launching this particular command. Why are my contain and root? It is actually creating the image in the backend. So this command is getting run when you are launching the srun. Okay, in the backend. So we are now inside the image actually, and you will not feel anything whether we are inside it or not, because in this case you can see, right, we are not the root user, we are the same user which we were in past, right? So here inside this, you can see you won't be able to do anything with means you can definitely set what kind of user you want to be inside the image, but currently we have set up like you are the same user, so all of your environment would be intact for you only. Okay, so in this case you can see I am inside the image and we provide few uh, examples and tutorials with each image. For example, PyTorch. So here some PyTorch tutorials are present, PyTorch examples are present. All of these you can try and test out as well inside this workspace folder. So this is the by default directory, so which we have set up. But you can see we have mounted our home as well, right? Using this container mount home. So you would be able to find it out, your DGX admin okay, DGX admin directory available here. So here you are now in your the home directory, but you are still inside the container. How you can verify? Simply by pip list. You would be able to see all my libraries are installed related to PyTorch, right? Which were there in when you were using Docker also. If you go out, let's exit it for a second. We have now came again to our bare metal machine, and now you do pip list, you won't be able to find even pip is installed. Okay, so inside the container pip is there, then there you would be able to run your workloads. Okay, now outside it nothing is installed, so nobody would be able to install anything unnecessary on your bare metal. Okay, so this is the one way to launch the image, or there is one more way, as I said. But this way, when you use the SQSH file, right, whatever change you make uh, in your image, it will get saved. Okay, but if you simply directly put the name of the image from ngc, which is nvcr.io/nvidia. Okay, it's not slash, it would be hash. With enroute, you just have to change this first slash to hash, then pytorch 22.0453. You can even launch with this. Okay, you don't need to use enroute import command. It will start importing that image. Okay, by default. So Pixis will take Slurm. Pixis will tell the Slurm to use enroute to pull the Docker image which is present at NGC. Okay, it will take some more time because it is pulling as well. I'm stopping it, but it will run that way. Uh, okay, let's rerun this because it is already present in my system. So I'm running this working. So you have any question in srun command? This is the Pixis. So here also they have run srun command. Here you can see they are running a container. You just put the container image here, provide the image name which is present on your system or on NGC or anywhere else, and then you can write any other thing. Okay, so this is one more example. We are just writing it for this is for PyTorch. You can use as batch also instead of using srun. So just additional flags has came on your existing Slurm environment. So I just wanted to know, do you want Slurm to be also taught in your environment, or this much is enough to how to run and change the flags? So any doubt in these flags or any additional thing you want it to have, just let me know. I'll just let you know whether it is available or not. So with this, you can just simply run this and inside this this particular container, and you will get into your environment. Here you are providing the mount as well. So mount will be helpful when you want your bare metal data to be present inside the container so that you can use it inside the container with all the changes that you want. Okay, I'll be using the same thing. Currently in my home directory, there is my code available which I'll be using. So same thing you have to do, either mount the home or you can mount even your RAID directory as well with the help of this flag uh, container mount. You just have to provide the source path and the destination path. So whichever, so but it should be, you should be having the access to that particular directory, then only you'd be able to mount it. For example, your own directory, your own RAID directory. And finally, you will be inside the image, and let me open one more tab here. Okay, here if you do SQE, currently nothing is currently one thing we ran, right? We are inside the image, right? Because we have ran the srun command here. You can see pip list also. All the libraries are installed already. Now here you can see my my particular job ID 113, which I ran, is taking the entire DGX. But if you want, you can change the number of GPUs allocated to particular user as well, and accordingly it will take. And if I launch one more now, currently as I'm taking all the 8 GPUs, the other job will be in the queue. It will not run. Okay, it will be in the wait state. Once I'm done with the first user is done, then only the other user would be able to launch. So see, that's why it is a shared system where you would be able to do the task accordingly. So you can manage that as well. How many number of GPUs you want to give, how much priority you want to give, all those things can be done with Slurm. Okay, so I'm inside the system. Let's run the. So now again the same thing which Utkarsh showed you, right? You are inside the image. Now you can run a Python code here because you have everything available here. So I'll be running the same code. It is already available in my mounted directory, which is DGX admin. The same SDP code is available inside this NVIDIA directory, NVIDIA SDP inside this train directory. Okay. Here you can see all the codes which Utkarsh showed, main.ddp, main_ddp and main.py is available. So I'll be running the same. First, let's run the NVIDIA estimate to see all the GPUs are available or not. Yes, all 8 GPUs are available with 80 GB each. Okay. I will not be running everything from the scratch. The same way which he ran, I'll be running quickly to show you. Torch.main.py. You can run Python main.py also. This torch run we just created for multi-GPU task in PyTorch. Otherwise, Python command, this is nothing but Python command only in the backend. So again, you can see one epoch is started and it is going to utilize my GPU. Let me apply watch NVIDIA semi. Okay. So here it is utilizing one GPU because we have mentioned CUDA visible devices equal to one means this device one. Okay. You can mention device 0, 1, 2, anything depending upon which GPU you have been allocated. Okay. So I'm running the code on the device ID 1 and here it is utilizing that particular GPU and it is taking how much, let's see. Any questions you have, you can ask with this run command.
So till the time this runs, let's go back and what we are running the insights of it. And one more thing I want you to know is the GPU utility.
So it took 1 minute something seconds to run this 391 iteration. That is one epoch. Okay, let's stop this. 1 minute something 11 seconds, right? And let's run the multi GPU code as well, which Utkarsh also showed.
But this is actually occupying 20 on this I'm running.
So we are using DDP here. So DDP, we will explain in much deep detail also about the DDP, and I have shared the links also how to use DDP to run multi GPU training, right? So oh sorry.
But this you will notice it's not good at all because it's going up and down, up and
Okay.
down.
So here we are going to use all 8 GPUs. So let's provide 8 here. And we only have one node available in this particular machine. So only node added is one only, right? So see, you can see it is working on all 8 GPUs. You would be able to verify it soon. Here you can see data is started loading on the GPUs because memory utilization has started. As you can see, the GPU utilization just started because we have now just reached to training part. So you can see it has trained in 163 milliseconds. Sorry, not 8 seconds. It has trained in 8 seconds 13 minutes. So how much improvement you are getting from 1 minute to 8 seconds? It is almost like 60 by 8, almost like 8 times improvement, or approximately 8 times. Why you are able to get this linear you can say performance. When you are increasing the GPU, you should be facing some latency or some performance degradation, right? But with NVIDIA DGX, which is the state of the art machine, here it has Mellanox cards available, which connects this with Mellanox NV link NV switch cards available, which connects this GPU with other GPU so efficiently that the GPU to GPU and CPU to GPU communication is very fast. Like it's in 600 Gbps or so, which Utkarsh has also showed in its one of the starting slide. So that's why you are able to get the linear performance when you are increasing the number of GPUs. Okay, so this was srun command. We can also launch sbatch command as well to launch in a bash format. Okay, currently we entered into the container and then launched it, but sometimes you would require just I would want to run my code is ready. I just want to run it, and it should run it for X amount of time depending upon the workload size. So in that cases, people use sbatch in srun, right? Sbatch in slurm. So let's go back to our. So now I'm not inside my container, right? I'm pip list. I'll do to verify. I'm outside the container. Let me see if there is any question. Yeah, we will share the tutorials recording just after the session. I'll only take 6 to 7 more minutes, and then we'll be done. So here, and I'll share the recordings with you all after the session, and everything would be shared in the Slack channel. Please join that. I would request you and add your teammates as well. So here I already have one bash command, bash script available, which I created. Let me just open it and I'll explain you what it is doing. So srun command, you understood, right? You can provide proper flags to run the command. So let me just show you that command also again. This is the command I used earlier, right? Which was taking, which was where we provided the container image path, where we mounted the home directory, where we provided the number of GPU using hyphen hyphen gres, where we provided that we want all the you can say I want everything inside my I want all the resources uh, inside my container. Okay, so inside the container you will receive all 128 so cores which are available inside in this image. Okay, sorry, in this machine. So when you use nproc, so all the resources will be present there. So when it comes to a large data loading kind of application where RAM requirement would be high, you would be able to use this very efficiently. But we will definitely split you all with a proper amount of resources so that there will be no biasness between anyone. And when you use hyphen PTI flag, you will be inside the interactive environment. Now let's run this with sbatch as well, bash command also. So I've created this nvidia.sh file. You can create anything like job.sh or anything. I have mentioned the job name as well. Okay, so when you run sq, right? So your job ID is present, partition is present, name present, user present. It will allow you to understand which user is running what task, and based on the things he mentions, and which are by default things also. So with this, with SRN also you can provide using hyphen J flag my job name. So you can provide job names like TensorFlow underscore maybe version you can put. Okay, so that everyone can understand. Okay, TensorFlow code is running there, and which is very important for that user. I should run it later on, something like that. Okay, same with Docker also. There is a flag called as hyphen hyphen name, which you can mention so that others user can understand. Okay, Utkarsh is running his code on the GPUs, and Bharat is running the PyTorch code on his GPU. So in Docker also, Docker run I don't know. I was a little bit away at that time. You can use hyphen name flag to mention the name of the user, and you can also mention maybe with what thing you are using, maybe a PyTorch code, okay, or a medical imaging code, so that other users can understand. Okay, he's using a critical task which is provided by the professor, so I'll run it later on. Okay. Uh, so otherwise, what will happen? You will not be able to figure out what container is run by which user. Okay. So it is always recommended to add hyphen name flag in your Docker run. It was, and same way with SRun, you can mention the job name. A user will automatically come. You don't need to specify. You can provide output. You can save your output logs which are coming while running your workload. For example, this torch.main.py I'll be running. So whatever things are getting saved, means logs are coming, it will get saved in nvidia.output. Okay, you can save it in nvidia.sh, you can save it in nvidia.txt or any other name you can give. You can provide time limit also, that uh, and you can also enable the time limit in your Slurm environment, that every user can launch one job maximum for 1 day. Okay, those kind of things also can be managed in Slurm. So here I have just mentioned that I will be running for 1 day. If my code is so big that it would take uh, 2 days, 3 days or so for running all the epochs. So all those kind of things you can do. And accordingly, later on when you come back, you can run it again. You can provide the GPUs, how many GPUs you require. So I'll require one GPU, for example, right now. So only it will take one GPU. You can provide what command you need to run. So just think about, okay, my code is present in this directory, NVIDIA. I'll just do ls/home/DGX admin inside this NVIDIA. Inside this is NVIDIA and this NVIDIA same. Okay, because currently I'm in /home/DGX admin, where my NVIDIA directory is present and my nvidia.sh bash file is present. Okay, so I'll be running this bash file. So what will it will, I'll tell you what it will do. Inside this train.py. Okay, when you, so here I did ls here, and you would be able to find my code is present here, and I want to run this main.py. Okay, using this nvidia.sh. So what nvidia.sh will do, it will run a srun command only. Okay, with these flags also enabled. Okay, which we have not explicitly mentioned. You can also write these flags also here. For example, if you want to write container image wala flag here. Okay, so what you can do, you can write hash sbatch hyphen container image equal to this path. Okay, and you don't need to write in srun again. Okay, so this is my overall sbatch uh, bash script. Here I am going to do these all tasks. Okay, I am going to run cd because I want to be inside this directory. Once I launched the container, okay, once my container is launched using srun, I want to be inside. So here, so what it is doing, let me just, sorry, it is missing some connect, but I'll be doing it, explaining it again. Here with srun command, you would be launching this container and you would be going inside the GPU. Okay, inside the uh, container image. Okay, now inside the container image, you will be launching the commands which are mentioned here. Okay, you can see we have just read cmd. Okay, we have created a cmd variable. Inside this, these commands are written. Okay, cd to this particular directory, then we are echoing it that I'll be starting the training and then running this command, right? Actually, there is some changes in the command. I'll just do it. I just noticed. Okay.
This difference is much more significant on DGX.
Okay, now you can launch it, launch the same NVIDIA pillar. First, let me just open it again. Yeah, now you can use this sbatch command and it will start running this Python, this particular command lines, okay, which is present in your code. Okay, so this is the way you can, and right now I'm outside the container. Okay, list again, I'll just do for you. Okay, so as batch, now you can provide how many nodes you want to work with. So currently we only have one node with 8 GPUs. Okay, when you club all the clusters, slum cluster, you would be able to launch multiple nodes as well. So there you need to provide the MPI, which MPI you want to run. Okay, multi-processing you want to run. So there, that in that case, you can launch the same job on n- more than one node. One node has 8 GPUs, so you would be able to launch more than 8 GPU, launch on more than 8 GPUs as well. Okay, and there also you'd find the similar kind of performance, means in the linear scale. This is hyphen nodes equal to 1, and after that you just have to provide the image name, the script name. Okay, now it is launched. It has submitted the job. You are still outside the container, but it is running in the backend. Okay, you would be able to see I'm outside the container, but it is running in the backend. If you use SQ, you can see my 114 job, which I just launched, is running with the name NVIDIA job on a user DGX admin, and it is utilizing the IIT B DGX, and currently it is utilizing one GPU only inside it because we have mentioned GRES equal to GPU 1. Okay, so you can find out whether how are my logs using NVIDIA output, which you mentioned already, that to log uh, your workload. So here you can see the code was not working because of that, but it has started running. That's why the code throws some error. But here only everything is running, right? And here only it is everything is saved. Okay, so with sbatch and srun you would be able to run your commands easily. Okay, so that's the two ways you can launch your containers. One is srun, which and other is sbatch, which anyway is going to use srun only in the backend, but it is more flexible in the way ki you will be outside the container also, and you can leave the workloads. It will run in the backend. You don't need to worry about it, and you just need to monitor your SQ whether it is stopped or not. So currently the code has stopped, so that's why my SQ command is showing nothing is present. You can cancel your uh, work if you want. No, my I want to cancel whatever I has launched. You just use s cancel and provide the job ID. Okay, so that way you would be able to cancel that particular job which you have launched, which by mistake might be not which you don't want to run. Okay, so those kind of things you can do with this Slum. So these are the basic features of Slum, and on additionally, Pixis has added the container feature using en route. Okay, any question here? So these are the just theoretical slides that you can launch on multiple DGXs as well. Currently, I launched it only on one DGX. You can launch on multiple DGXs as well through Slum, and you can do multi-node training. So whenever you find this GPT-3 kind of models are getting trained, right? So they use these multi-node, multi-GPUs like in hundreds or hundreds and thousands of number, and then only they are able to train these huge transformer based language models. So these are what you will get: low runtime overhead. It runs very fast compared to normal run. It has scheduling features, all those things are available in Slum. So this is basic Slum slides. I'll be able to share with you and some um, open tutorials also so that you can get through it. This is what we have created on Slum on our DGX. This is our DGX 800. You might have seen. On top of it, DGX OS is present, our own OS, and on top of that OS, either you can take our own OS or you can use RHEL or other OSs as well. On top of it, Slum environment is present with a master node, management node, all those. And here we have used NVIDIA driver, which will communicate with your GPUs to visualize, which has CUDA and NVIDIA drivers available, which will communicate with your GPU, right? And on top of it, we have NVIDIA Container Toolkit to communicate your container runtime on GPUs. Okay, to communicate your containers on NVIDIA GPUs and provide the CUDA support. Uh, Here, en route is again by us. So that's why all these three things which are in green by us, whereas Singularity is an open by is by some other you can say XYZ company, which also supports Slum. So these two things you can use to use the containers and to run on your bare metal system, which is DGX. Okay, so Pikes is I already explained. It's a Slurm plugin for Enroute by simple mean. So whatever things you want to run, whatever command you are running with Enroute, you can use the Pikes features to integrate these to integrate the Enroute part into the Slurm. Okay, into the srun command. Yes, that's these are the some examples which are also present. You can launch, for example, container name you can provide here and container. So you can provide the container name as well, just by hyphen container name. We just use container image, but you can provide that as well so that others can you see it who is running again. Okay. What command you want to run, you can mention at the end. Okay. These are again a few more examples which people have used. Okay, you use SQ to visualize what thing you want to which job is running on your environment. Okay, this is sbatch command. You can add few more features. For example, you want to go into a particular directory. Those things also you can mention here. A number of tasks you want to launch. All those things you can mention. Here we will be going to use two nodes. Okay, two nodes of the GPU. Sorry, two DGX nodes. So that's why I have mentioned hyper MPI PMX. So it will run on PMX. You can say MPI runs to launch your workload, to launch your container on multiple nodes. Okay, so whatever thing you want to run. For example, in this case, we are running a TF-CNN benchmark code. Okay, so if you mention number of nodes to be two, so it will use PMX to launch it on the multiple GPUs. Okay, multiple nodes. This is the final links, all of these which you can see how what is Enroute, what is Pixis, everything is available in these links, and I'll be sharing with you this particular slide deck on the Slack channel. You would be able to read about that and let us know if you have any question. Yeah, that's it with the slides. If you have any question, please let me know. And you want anything to be covered in the next session, which we'll be having, and I think in third week of August, we'll be having a session for 4 to 5 day session. There itself, we will be able to cover whichever you feel is required after this session. Okay. Or right now also, if you want to add, I'll note it down to cover it in the next slide, in the next session. Thank you. Any question, please let me know. So you can ask questions even in the Slack channel. I request you to share within your community or within your um, user groups as well, or your groups to be there. We also will have workload specific trainings also in coming weeks, where we'll provide how to accelerate the codes in NLP, computer vision, and all such domain. We'll also cover this same code, but in much more detail at that time. Also, a few of our libraries will be covering. So it would be good if you ask any related queries in that Slack channel. So, thank you. So I'll share the recording with you soon. Thank you.